Good morning and welcome to day 4 of the Spaceport America Cup. I'm Logan Herrera, the Ezra live streaming lead, and here with me is Chris Lopez from Spaceport America. Good morning, Chris.
Good morning, Logan.
It is a beautiful day out here at the VLA. We're an hour earlier than yesterday. Our launch window is opening 1 hour earlier. Calm winds, clear skies, things are looking good. What can we expect today, Chris?
Well, if you were looking for that dramatic effect, waiting to that last minute, it's here, Rocketeers. I hope you're checked in. I hope you're ready to go. You're not going to get better skies or better winds than we have this morning to go ahead and go up. I don't see a cloud in the sky this morning, Logan. It is gorgeous out here.
I'm loving it. This is great rocket flying weather.
It's a bit hard to hear outside the
We've
thing.
heard
Is that
there
right?
are a few teams on the pads ready to go. We're looking forward to have an opening salvo shortly after range open. What else is going on today, Chris?
No, I know. Last count, when I was driving around base camp, looked like 9 teams at about 6 o'clock were in their final preparations, which was going well. So I know range closes here at noon.
Mm-hmm.
After that, we'll head back to Las Cruces and go to the Pan American Center for our closing ceremonies this evening. But today, I think it's a story of perseverance and just making sure that we don't get complacent. Anything working with high energetics, and it's late in the week. Are we still making good decisions, encouraging everybody, and even our ground staff that's been working all week? We go through the same thought process. Let's not get complacent. We still have an open launch window that needs to stay safe, and open range operations that we need to make sure stay safe.
Totally agree, Chris. We need everyone making the same quality of decisions all day long. You're still going to be drinking lots of water, still visiting the medical tent if you need it, free of charge. We're looking forward to teams maybe who have had to correct some deficiencies in their rocket, getting those corrected to the quality we need to launch here. And they'll be well positioned if range safety signs off and we are ready to go.
No, they no doubt. Again, it's a fabulous morning. I'm looking at some of the teams still getting ready here. Far cry from yesterday's weather. Those dust storms and dust devils just shows you how quickly situations can change.
Absolutely. We were indoors in the live stream control room, and we got dust on us when that dust devil came through.
Oh, I believe it. And for those Rocketeers out there watching this year's live stream, seeing what to expect for next year's event, these are the learning lessons. Be prepared. By the time you hit New Mexico and you hit that first judges check-in, that first day of convention, make sure you're prepared. I know it's an old adage. We heard it all the time. No better time than the present. That's true in your preparation. And we talked about at the end of the week, making sure we're still making good decisions. Now let's start, we're already starting to prepare and take some actions for next year because we're excited to be here. But there's a difference between being excited and being prepared. So all of you that are looking out there and watching this to see expectations for next year, start your preparations now. Get ahead of the game.
Absolutely. And Chris, something I think we also emphasize to the teams is that being prepared doesn't just mean thinking about it really hard in advance.
That's very true. Again, it may sound cliche-ish, but the journey of 1,000 miles starts with
a single step.
A single step. There you go. So it's in that regard, and what I've learned when I've watched some of our commercial customers here, they're innovating. They're trying new items. Progress. Don't let perfection be the enemy of good.
Absolutely. There's nothing quite like getting real-world experience. You learn so much from the first few times you take out a new system. And the most prepared teams, the most successful teams, the ones who are getting those early launch bonus points, I bet they have been taking their rockets out for prep runs before they arrive.
No doubt. I've heard stories of students, just rehearsing. They try to get up back at campus. They get up at 4 a.m., try to simulate conditions that they're here. When they're rubbing the sleep out of their eyes still, they rehearse assembling their rocket. They rehearse their safety checklist. They rehearse their technical checklist, their electrical connections. And so again, just step by step by step, and then it becomes a habit rather than having to think and wonder, are we doing the correct thing when we get out here in the desert? Because there are so many variables to manage out here, and we here at Spaceport, we try to help make sure everyone does stay safe. We try to take a lot of those variables, but here's the reality. It's going to be challenging for you. Our sponsors want to see how well prepared you are. I was talking to one of our sponsors, and it was remarkable how they were talking about the challenges that this environment brings, and even the winds come in. How are the teams prepared? and even prepared with contingency plans.
Exactly, exactly. I think part of being prepared is being flexible, being ready to handle those unexpected situations, having the team culture where you can have something unexpected happen and be able to recover. You understand your system, you know its capabilities and its limitations.
No doubt, and know your own limitations. I heard one of the team safety officers earlier this week talk about, folks, I know we worked hard all year, but I'm noticing we're starting to make bad decisions, and we weren't quite as well prepared as we may want to be.
Mm-hmm.
And the team lead actually called the project in the name of safety. That's the right call. We want everybody back home at that dinner table. Every night we're working with high energetics.
Mm-hmm.
These decision points are extremely important. Now that goes back to the preparation. We know what decisions need to be made because we practiced making those same decisions back on our campuses through the year, and now when we got out here, we can execute.
Totally agreed, Chris. And I think we're still seeing teams coming in, getting prepared and ready for this launch. We are waiting patiently for that range open.
Yeah, I'm looking for those go flags, and I don't see one up quite yet.
So they're still getting ready. We still have some time before the range opens. We'll be looking for that red flag indicating that energetics are armed and the last people are clearing the pad. Our sequence is first green flag, then yellow flag, lastly red flag. Those let us know who can approach the pad. It's a traffic light indicating the status of the energetics on the pad. And then and only then do we get the countdown and push the button.
No, well, let's not forget about the second part of this preparedness. We always talk about launching those rockets. Now it's time to recover and understanding what's in that recovery. What if that chute didn't deploy? How do we know that the energetics are safe to approach that rocket? But here we go again, preparation with our team. Do we have enough water? Do we know about where we're going on the map? Did we check in with our safety officers? You can't go out and recover your rocket without that Da Vinci backpack. Are we prepared of how do we communicate? How do we recognize stress in ourselves? So again, I know I'm talking about the human element, and we've been talking about the rocketry all week, but don't let this gorgeous morning fool you, folks. I know we've been challenges of the wind all week. We have a gorgeous morning this morning. We are at a high altitude. We can get dehydrated very quickly. Please continue to take care of yourselves and each other.
Yeah, and Chris, when folks are out recovering their rockets, how do those backpacks, check-in systems, how does that help you as an organizer maintain situational awareness?
Oh, it is a tremendous help to help keep all of you safe with those backpacks. And we know where you're walking. We can actually trace you on a map. Our friends at Da Vinci do a fantastic job. This backpack is very lightweight, and there's two radio systems in it. One for voice communications, one for GPS communications. And when we make the requirements that you check in every half hour, those are hardline, strict communication guidelines that there is no negotiation, and that's for the safety. So teams will check in every half hour, but it allows us to keep those open comms while you're out in the desert. And sometimes we get questions such as, hey, I'm coming up on a fence, am I allowed to cross it? Hey, I may be team 142, but I found team 32's rocket pieces because of the labeling, and we can call that in, and it actually tracks. We'll pinpoint the GPS points on where we may find that debris, and it helps your fellow rocketeer out. But even more importantly, we're not littering the desert full of rocket pieces. We don't want to just leave our spent rockets out in the desert. We want to be good neighbors and good stewards of the land out here. But those GPS backpacks and working with it, tremendous help to make sure we know everyone's staying safe.
Glad to hear it. And I think that's a great example of how there are human procedures and technology that are working together to keep this event running smoothly.
Yeah, no, you make a great point. That human technology and the technology side, you guys are probably noticing I work a lot with the human side of things. And whenever you get to that decision point, is it I'm not sure. We do have an anomaly on our rocket. Maybe we have to change something with our altimeter, with the wiring harness, and you're stepping back and saying, is this the correct decision? Don't sacrifice a quality decision just for the sake of speed. And it goes back to what we said earlier, that excited versus preparedness. When we rehearse, we know what decision needs to be made. If we have a new decision we come up on, now let's not get excited. Let's make sure we're making the right decision. And we see our customers here at Spaceport America go through that same value chain of making decisions, because we're dealing with people's lives and the high energetics. I don't mean to be dramatic about it, But again, it's an important part of our business in the rocket industry here.
Right,
Keep
and
everyone safe.
that's something we prepare for. And we've seen some rockets with off-nominal trajectories.
Yes.
We've seen some have some motor problems, have some aerodynamic fin breakup problems, and that's why we designed the range the way we do.
Oh no, the range design is incredible. I mean, going through and we worked again. The preparedness we start looking at these designs sincerely. We've already taken steps this week to start preparing for next year's preparation. Next week, we're going to start assembling quite a bit of data, and then over the next month, collecting the data, correlating the data, and then figuring out what adjustments need to be made to make a better competition for our sponsors, for our rocketeers, for the whole experience.
Great. Thank you, Chris. Looks like we're going to send it over to the other crew. Thank you for coming up here.
You got it. Anytime. My pleasure.
Good morning, y'all. I'm out here bright and early in the commentator booth and not outside. We were having a little bit of technical difficulties, but we are here on the fourth and final day, super early, and I am here with the team from India. Would you guys like to introduce yourself?
Yeah. We are Team Samad from VIT Vellore, India. We are participating in the 10K COTS part of the SA Cup, and we're representing India as a whole, but VIT Team Samad specifically. So we'd like to give a small shout out to our captain Jatin Dhal, our SA Cup lead, Supreet D, who is right now at the launch pad preparing the rocket for us. So yeah.
Awesome. So you guys were like the only team out there when I went. How does it feel to be the only ones out there?
So we actually wanted to launch yesterday, but were unable to because of the heavy winds. So we are back here today, ready to launch, finally ready, and going up for it.
Awesome. And what can you tell me about your rocket? Any special features?
We have actually most of our rocket is COTS, but we have a Spark which we have built, which is our SRAD flight computer, sorry. And we have built that right now. Richard can tell you more about that.
So our Spark is our flight computer, and our flight software, which is called Flare, they're working together to send us telemetry. Yeah, we're going to record the flight data for later, test it out, see at what point of the flight what happens, if the parachutes are releasing properly, everything, stuff like that. This is mostly for us to also understand later if anything goes wrong in our flight, which it shouldn't, because we've done a lot of prep work for till now, but just for the sake of being able to learn from our mistakes. Yeah, so we did it accordingly to our needs.
We also had a 10 descender system for a recovery mechanism, which we got a podium session for. This being our first launch, we are very well prepared, get all the backups ready, and just ready to launch now.
Is this your guys' first time here in the competition?
We actually participated in the online session which happened 2 years ago, but last year we couldn't participate because of visa issues. So this year we are back here, finally ready to launch with our rocket Vajra. And right now it's out there, kind of hands trembling.
Yeah.
You can go.
Okay, so
what can you tell me about the visa process to get here with your rocket?
So after the pandemic, visas were kind of an issue, especially from India to USA. So there was normally a wait for an entire year. So we had to, last year, so we couldn't actually get to the launch. So this year we tried again, we tried to expedite our visas because of the competition, and there were a lot of ups and backs, and you have to go there, back again, and we finally got it through, and that was a huge pain, to be honest. Separately, even getting the rocket from India to over here is a huge pain in itself. So sending it by sending it by plane or like shipping it over here, it one costs a lot, and two, there's a lot of national security issues because it's a rocket and it kind of looks like a missile. So we need like certificates from the defense ministry. So we kind of got it through on our check-in luggage. So and like rocket's kind of smaller, so let it pass, and we had all the necessary letters and all that. So we kind of sailed smoothly from that. But the couple of days where we had to first ship it, then get it back, and then what do you call get in our planes and fit it inside was a huge, miss and pain and overall.
Wow, so how long did that process take, like in total?
It was we started for the visa. We got it through like a month ago. And the last like week before coming here was we just got the shipment done, all the letters and everything ready, and we sent it out. But then the shipment stopped on Saturday, where they had to check for what do you call customs in India, and they stopped us because we did not have a letter. So they stopped it in Delhi, which is like very far from where we actually stay. And then we got it somehow from Delhi to Mumbai, where our flights were from, and that also because is not a working day, so you have to wait entire day for them to see how that works. So that 2-3 days passed in that, and then our flight was on Tuesday. We got the rocket on the Monday. We packed it up, everything was done, and then like packed it up, and then somehow we made it on time. It didn't stop in U.S. Customs, which was amazing, and after that things were a bit more smooth sailing. So we are actually very lucky and very happy to be here. This being our first launch, it's just, it's a great feeling inside.
Well, I am so glad that you guys were able to get the rocket here. What is the thing you guys are most proud of from your rocket?
We've, from our rocket, we're most proud of the fact that we've like actually physically here with the rocket. We've prepped so much for this. We're confident that we are going to like get like it to launch. Everything will properly work, and we have backups on top of backups for every system that we have. We have our own SRAD components, and so like it's a whole like conglomeration of everything that has like we've built up till here that we're proud of. Nothing in specific, but mostly we're proud that we're representing India, we're representing Team Samad as a whole here, and yeah. So
Awesome. Would you like to add anything?
Just that all the people who have worked behind this, people who could not be here also, they have put a lot of work in throughout the year, and people on the launch pad right now who have been done multiple tests. See, getting permissions for a lot of things also is a lot of problem. Especially black powder is not available very easily in India. There are a lot of restrictions for that, so we made our own. Then we tested that with the American one. So that was also front and back during that. So we are a lot of proud of the entire process, a lot proud of the lot of people who have put their hands behind this. A lot of work has and a lot of pain, a lot of tears and blood has gone behind this. So
Awesome. Oh, you have something to say?
no, that's all.
Oh, sorry. Well, we have another team member here. I don't know if we want to switch headsets, see if we can have him talk about his experience.
Uh, so yeah, I think even in India we don't get permission to launch the rocket vertically. So even with that, we are pretty confident that we can launch the rocket today. All the other teams, they get the chance to launch it vertically. They get the permission to test the black powder here, and we couldn't get it. So it's amazing that we could make it here. So I hope that it goes well. Even if the result doesn't matter, the hard work we have put in speaks for itself.
So you mentioned that you weren't able to launch, like test launch. What is that like and just being here
Uh,
without testing?
so yeah, it's kind of a disadvantage because we cannot launch because other teams have an upper hand. They can like test multiple times and they can do like even the minute changes that they need. So, but we have made everything else. We have made it perfect. So we are confident that it will launch. So
So is this the first time you guys are launching this rocket ever?
yeah,
Yes.
it's the first time.
Oh my goodness. Well, let's hope that it works. Is there anything else that you guys would like to add? Any shout outs, anything?
Just a shout out to whole team Samad. They've worked a lot. We have worked from 9 to 1 every day in the night. All the classes we have missed just to wake up late in the morning. So I hope this will pay off. Yeah.
Is your whole team here with you guys, or are you guys
No,
missing?
only 8 of us are here. Rest are watching all online.
Oh, okay. Well, shout out to you guys. Hello. Well, thank you guys for being here with me. We'll see who we can go back to.
Earth.
Awesome.
Earth, our blue origin.
We've sent robotic probes all over the solar system, and it's full of wonders. Gas giants, rocky moons.
Despite the variety, despite the wonder in the solar system,
Earth is the best planet.
There's no place like home.
There is no place like Earth.
All life on Earth are uniquely matched to this planet. There's nothing like it anywhere else in the solar system. Not even close, no way.
Earth has things that we need to work on in the here and now.
But there are also long-term problems.
We can't wait to work on the long-term problems. We have to work on both.
We have no choice but to preserve Earth.
Preserve this planet, this one.
we get to focus on the future, and the future is nothing without Earth.
At the Kansas City National Security Campus, our work is more than a job. It's a mission to deter our adversaries and assure our allies. Since our start in 1949, we have seen dramatic changes in our business, our country, and our world. But one thing has never changed: our unwavering commitment to the mission. Our mission defines our past and guides our future. We have a proud history supporting the nation's warfighter. Our brothers and sisters in the Air Force and Navy bravely put their lives on the line every day. That's why we put our best foot forward, making sure the nation's nuclear stockpile is safe, secure, reliable, and effective every day. It's more than a job. It's a passion and a partnership across the National Nuclear Security Administration and its 8 national security labs and sites to support the nuclear deterrent strategy and ensure our country is prepared to defend our freedom. It's why we have a relentless pursuit of perfection and exacting standards of quality. Our superior performance is reflected in our work and measured in our dedication. Our world-class team of engineers, scientists, and technicians employ innovative, high-tech solutions and develop new and emerging technologies like digital manufacturing, simulation, and augmented reality to solve complex nuclear security challenges. For 70 years, the NMSA and Honeywell have worked together to protect our country. Today, we are stronger, faster, smarter, and more focused on our mission because we do work that matters. At the Kansas City National Security Campus, we are the mission. Our mission is to support the warfighter and keep our nation's nuclear stockpiles safe, secure, reliable, and effective now and always.
Hello again, I'm Logan Herrera, the Ezra live streaming lead, and I'm here with Scott McLaughlin, the Spaceport America director.
Good morning, Logan. It's good to be here. We have a nice morning. Feels really good compared to yesterday afternoon, but I think the winds are going to pick up again this afternoon, but hopefully get all the launches off before then.
Absolutely. We just got word from range operations that solids has gone to red flag, so we're expecting a few rockets, roughly 5 or so, in the next 10 to 15 minutes. We'll see if that goes according to plan, but that's where the range status is at right now. What have you taken away from the event, observed over the week?
I'm just always impressed by the excitement of the students and for how long they've been working on this, since October, and then they get out here and they're just full of energy. Tuesday at the convention center was full of energy, and then every time you walk around the, I call it the pit, there's just lots of energy with the students, and it's just consistent. And even in when they have some failures and problems and mistakes, you can still feel the energy. I mean, they like being here. They like the contest. They like what Ezra set up. It just feels good.
I think that's one of the beautiful things about rockets is no matter what happens, it's going to be exciting.
Yes, that's one way to look at it, yes. Although I don't think we counted on a dust devil going through the middle of camp yesterday. That was some extra excitement.
That was. Everyone got a layer of dust all over their body. I certainly enjoyed being able to clean it off at the end of the day.
Yeah, and ironically, the medical tent got hit the worst. So, but we're back in operation. Of course, we have 24-hour full-time security and medical. So we have a medical trailer instead of the medical tent because the medical tent didn't survive the dust devil. But we're still set up and taking care of cuts and bruises and scrapes and bug bites and trying to get people to drink water. That's been the biggest thing, drinking water and electrolytes. So.
Absolutely. That's been one of our key messages on stream too, is letting the audience know you need to be drinking water out here. If you know folks out here, tell them to drink water.
One of the things I've heard, I grew up out here. I was gone for a long time, but I grew up here, so I'm used to it. But what I've heard is that people from back east or other places where the humidity is higher, they know they're sweating because they can see the sweat. But when you're out here, it's so dry, the sweat immediately evaporates and keeps you cool, which is what your body's trying to do. But you don't realize you're sweating, so people are not reminded to drink water in the same way. So I've even heard of when they do maneuvers out here and stuff at White Sands Missile Range, they go around and they order people to drink water. They hold up a quart of water and they order them to drink the water. So I don't know whether I have to resort to that, but maybe we can put that in the rules next year.
Well, I like the way you think, Scott. I'm supporting just about anything we can do to get the hydration levels up out here.
Yeah.
And returning to that medical tent that you've now replaced with the trailer, I think that connects with the theme we were just talking to Chris Lopez about resiliency and being able to handle unexpected situations. How have you seen that play out over the week on the spaceport side and on the student side?
Well, I mean, it's really an attitude, right? If you come into anything complicated with the attitude that that you're not going to have problems, and then you're already unprepared. Anything complicated means, there's so many degrees of freedom that at some point there's we're all engineers or related to technology. Well, there's a multiplicity, there's an exponential in terms of all the things that can happen, and you simply can't take care of everything. So you have to start being prepared to have extra parts, extra tools, contingencies, and then you have to be prepared for the unknown, meaning you have to be able to just regroup and figure out what the new problem is of the day and how you're going to solve it. And if that's your attitude, that you're here to solve problems no matter how they show up, with a little bit of optimism, then you can get through this. But I think a lot of times people prepare correctly, but they prepare for all the things they know. They don't prepare for the things that they can't quite imagine, and that's where they make a mistake. You really have to be sort of flexible and being able to go anywhere to solve the problems. And so we've learned that. I mean, having close to 2,000 people out here at a time is something that we're getting better and better at. But some of the student groups, you can see that they're very well prepared. Some of the newer ones, they're not. But when it comes to working in the industry, this is such a great contest for them. This is such a great experience. So that they're learning that Murphy is out there and waiting, and Murphy will show up when you least expect it. So and look that up on Wikipedia. Murphy's Law actually is there. So
great. And I know that's a theme that sponsors have been repeating for us, that they enjoy meeting the students and seeing them overcome a real-world challenge. How does that tie in with the narrative that you tell sponsors to try and get them to come out here, the value proposition that Spaceport America has, and the feedback you hear of what sponsors like about being here and coming back year after year?
Well, I think we were getting sponsorship going several years ago. We were doing well, and they were looking at it as an event, maybe to do a little recruiting, maybe a little branding, marketing for them. We were going pretty good, and then we had COVID, so we basically lost 2 years. And then last year we got going again, and I think we had a really good restart with the sponsorship. And what we heard last year was a lot of them loved the recruiting. They loved being able to come out here and talk to students who are hands-on. And then we have a few other companies, aerospace companies, that came out not to do recruiting, but because they're actually advertising what they do, their services and their parts, because they know they're speaking to the audience of future engineers who are going to buy their product, and they wanted to be out here, and they brought out engineers to have technical conversations. And what we heard from all of them, they were just very impressed with these students and their knowledge base, all the things they've learned over the last year, all the over the issues they've had to overcome, and hands-on design. And of course, these teams even have to do other things like raise money. Of course, they have to figure out how to get out here. There's a whole other set of logistics, which is more like a typical business model as opposed to a technical problem. So we've just heard that the sponsors are very happy and impressed, and a lot of them want to even go bigger next year. One of them is talking about having a tent outside the convention center.
Oh, I love that.
That'd be like a little student lounge, but it'd be sponsored by this one sponsor. So, so we think we can go a little bit bigger, although the convention center is kind of full. But a lot of them came out here. In fact, some of their tents are still set up out here, and next year we're also gonna try and figure out how to rearrange the logistics just a little bit to get the students and the sponsors even closer.
Well, that's great to hear. I'm glad there's so much interest that you're hearing from the sponsors, and I think it tells us we're having an important impact on the community when we're maxing out the facilities in the city of Las Cruces.
We're now one of the larger events for Las Cruces, and especially for the convention center. So, but the Spaceport America Cup, has been bigger than that. I routinely go to meetings with the FAA and Space Force and other folks who are interested in the future of space, and they now have hired people who have come to the Cup, and they've heard about it. If the older people haven't heard about it and they haven't been out here yet, the younger people they're hiring have heard about it and know about it. And it's really kind of a great reputation because, despite the wind and the rain last year and all the issues we have, the experience that the students go through for the whole year, and then the very challenging conditions we have out here for launch, coming out early in the morning, having to plan to get out here, and then having to go retrieve the rocket in 100-degree heat sometimes. All of that is lending to this kind of aura over the Spaceport America Cup of what Ezra has done. It's just a great contest. It's just gaining, I think, a really good reputation. And part of the reason we know that is because all around the world we're now getting these little pop-up new contests, and that are, I think, basically copying and mimicking, which is great because not every, even though we got 5 teams from Turkey and I think 5 from Australia, not everybody from these countries can come out here. So the idea that this concept that Ezra has been molding and shaping and improving over the years is spreading is really cool. It shows where the aerospace industry is going, where space is going.
And I think that's something that Ezra's really proud of. The original competition, IREC, has been around for over 15 years.
Right.
And we've been able to partner at Spaceport America for how many years now?
I think since 2017.
Okay, so several years now, and the reputation has been growing over time. The participants are now starting to reach higher and higher levels in their organizations, and we only expect the reputation to grow. How do you expect that to grow and evolve over the coming years?
I think one thing that helped is having Tripoli involved with the level 3 certification folks has really improved the quality of the rocket, and I think even this year, even more than last year, I was impressed that from when I first showed up in 2019 to last year, which was the year after COVID, that the quality of the rocket, the flights, you could just tell was much improved. And then this year it seems like it's even better. And I'm attributing that both to having Tripoli involved for every single team, and also I guess that you guys introduced a video review now instead of just paper or pictures, which I think gives a lot of interaction to the teams. So it just seems like the flights have gone off straight and true more this year than any of the previous years that I've seen. So I think that enhances reputation too, because it means that the quality of the rocket's better, it means that the safety is better, the risk is less, so I think we're all happy about that.
I wholeheartedly agree, and from the Ezra side, there's an entire army of volunteers helping to make this event happen. There are judges who are interacting with students all throughout the year, beginning from the application process, acceptance, technical progress reports, safety reviews, technical submissions, judging. There's a poster session in the convention center for technical awards, sportsmanship awards. There's a lot that goes into this event, and we really look forward to showing it off this evening at the award ceremony.
Yep, that will be exciting. So the award ceremony is kind of turned into a fun event, and this year we're doing it in the basketball arena in town called the Pan American Center. And so I think it will work really well because it's a nice, benches that slope down that will focus on the stage, and it will be kind of a different atmosphere. And this is our first time for trying it, but we hope that will be kind of fun and exciting. I think there's a lot of anticipation on the scoring, and the scoring is complicated because you build up points throughout the year, right? And then you get points for different things. So even if you hit your altitude, even if you get the rocket equation correct, you may not win, right? There's different reasons. And so I think that leads to a lot of suspense and anticipation at the award ceremony, and a lot of cheering, a lot of happiness, a lot of broken hearts. But that's the way it goes, right?
Absolutely, and I know you'll be on stage giving out some of those awards.
I'll be up there for a little while. I'm going to do just a little speech, a little morality play, if you will, of things we learned. That again, this is what I like about this, is it's set up it's so real world. That that whether you want to or not, as a participant, you're going to learn something, and you hope you don't have to learn everything in life the hard way. But they say experience is the best teacher, so that's the way it goes.
Absolutely, and to go into that scoring system a little bit, roughly half of it comes from pre-event technical submissions, where teams are graded on their engineering process and the quality of the decisions they're making. Then roughly the other half comes down to how their rockets perform and those bonus points for being ready on the first day. So I think that scoring system rewards consistency across time.
Right.
And a splendid rocket today might not be the winner, and a perfect technical report might not be the winner.
Right. Right. I know I used to be on a First Robotics. I used to be a mentor for First Robotics, and there was similar type of a scoring. And so if a team team might have different goals, right? A team might just want to hit their altitude, or they may have a payload goal, right? Or they may want to win. Like there are some teams I think who just want to win. They think they can win. Well, if you're going to do that, you need to understand the scoring, because it's not going to be about one thing, right? It's going to be about all these things. So understanding where you get points and trying to maximize each category, that's a key to getting to the Genesis Cup.
Absolutely.
Yeah.
Well, and similarly, teams can have their own objectives in this event. There are the technical awards. There are 4 of them, which cover specific topics that are distinct from this overall scoring system. Additionally, there's also a payload competition. So teams can set their own goals and go for one of those awards specifically if they so desire. Also, to sponsors out there, if you want to provide the challenge and the judges, you can sponsor your own competition and give out your own trophy.
That reminds me of what we've done locally. We have the Chili Cup. So for the local teams, and we're going to try and get some more next year, but for the local teams, we built this really cool trophy, which has a red and a green chili, which for New Mexico is the official state question, red or green. And we also have the only state in the union right now to have its own aroma, which is the smell of green chili roasting. So anyway, the Chili Cup is a particularly unique award that we're going to give to either this year it's University of Texas El Paso, New Mexico State University in Las Cruces, or New Mexico Tech in Socorro, New Mexico. UNM, we had 4 teams last year. But the UNM has some other things they were doing this year, so they didn't participate. So it's going to be a contest between the 3 to award the Chili Cup. So you're right. I mean, there could always be some more awards if a sponsor wants to help along and pick a category or do something special.
Yeah, and Scott, if a sponsor is interested in getting involved, how can they do that? Who should they contact?
So the best thing to do is go to SpaceportAmericaCup.com or go to the Experimental Sounding Rocket Association. We have a reel on Spaceport America channel on YouTube. So go to YouTube and look for the Spaceport America channel, and you can look at all our videos, and there's a recruiting video, and that would be the first thing to get the sponsor to understand, especially new sponsors, what this means and what they can do in the future. And then you can give us a call. We have a person here, Felicity, who is doing all the sponsorships, or just go to our website and enter in our forum, or give us a call. But we're happy to get started on that conversation, especially the sponsors who do want to do something unique, whether it's a trophy or a category or something to help the students. One of the things that they want a little more out here is shade. And we're not going to grow any oak trees anytime soon out in the desert, but we do have the sponsors who have some tents. I think we need to fit a few more tents in next year, so that would always be a great thing to sponsor and a great way to get the message out to the students.
Absolutely, and I'll also add, the live stream booth is air conditioned, so any folks out here who want to come give an interview with us and rest in the air conditioning, come over to the live stream building.
That's a good key. Air conditioning is key. We did get power out here this year, so we improved the roads and we got power, although we didn't get power to everything. the supply chain issue really affected transformers. I mean, we were seeing like 18-month delays on ordering a transformer. So, but we were able to hook up a lot of the power. So up here in launch control, we didn't have to inhale diesel exhaust all day long, and the live streaming trailer is powered. A few of the other sites are powered. We have food trucks out here, so when the students come out, they can get food, and when the spectators come out, they get food. So all those are powered. So that is all helping. And then someday we hope to get an extra building or two out here. We want to do, the vertical launch area is specifically uses our vertical launch license with the FAA to go vertical. Right now we have customers who only go suborbital, but someday we hope to go orbital. So we're interested in building some facilities that have payload processing and other aspects. We are building a launch rail next year, for example. So.
Yeah, and Scott, how do these capital improvement projects go into attracting more customers to the spaceport?
So, Spaceport America is pretty unique. When you look at the other major spaceports, they were all federally funded one way or the other. They got all their hardware, almost all of their support facilities from the federal government because of various aspects. So you have Wallops, which was mostly NASA funded. You have Kodiak in Alaska, which had a lot of federal funding. Of course, you have Vandenberg and Kennedy Space Center, and Cape Canaveral, which were Space Force and NASA funded. So you look at all that. Well, Spaceport America is unique because the state of New Mexico paid for it. The taxpayers of New Mexico paid for it. The genesis of it was our handshake deal with Virgin Galactic. And of course, we're seeing them fly now. It should be once a month. They're going to fly next week, they've announced. But the state of New Mexico, we have great weather. We have this great location. We're building up something we call Space Valley from Los Alamos to El Paso, where we're focusing on that aerospace ecosystem. And so the state of New Mexico has kind of taken a build it and they will come to some extent. We do partner with a lot of our customers, come out here and build their own facilities, but we also try and get a little bit ahead of them, especially for these early stage companies. They don't have money to build a facility. They need to get in operation, generate some revenue, maybe prove some technology. So we're trying to stay ahead of that as much as we can, and the state and the two counties, Doñana County and Sierra County, have been helping pay for that. So hopefully we keep that going a while longer till we get some more tenants and we're a little more self-supporting.
Very good. Thanks for explaining that, Scott. And how about the event itself? How do we pay to get all this infrastructure out here to handle 2,000 students?
Yeah, that's a tough one. The sponsors are a big thing. I think we raised about $220,000 this year, but the event takes something over $400,000 to put on, which seems like an incredible amount of money. But when you consider renting the convention center for a day, when you consider the Pan American Center tonight, when you consider one of the things we do really well, I think we're doing really well, is just the site logistics in terms of the medical and the security. Well, that all has to be paid for. It's most of it, a lot of it is our staff, our normal staff, but there's a lot of overtime to get the students out here every morning, 5 o'clock or 6 o'clock or earlier. So there's just a lot of extra expenses, all the tents, everything else. So we're keeping the sponsorships going and trying to raise money and help everybody out and have a good event.
Great. And how does that compare with the economic impact of the event as a whole?
That's a big factor for us. There's two things we always like is economic impact. That's why the spaceport is here. That's why the state of New Mexico initially funded it, was to get economic impact. And the other part of it is getting the word out there that Spaceport America exists as a licensed horizontal and vertical launch facility. We're also working on a re-entry license. And our goal, our vision, is to be a major spaceport, in the coming decades for the United States. So we're happy with kind of how we get that name out there and get the word out there. But the economic impact is really important for Truth or Consequences, a great little town, and the city of Las Cruces.
Yeah, I recall from our press conference earlier this week that the number for last year was over $1.5 million.
Yeah, we think that, and we'll do some more analysis this year to show what that economic impact is. But it's really important, and we feel good about that, and we like the students spending money locally, of course. So that's
what we want. It's a great impact. Thank you,
yes.
Scott.
Yeah.
It looks like we're headed somewhere else to see some rockets launch.
Good morning. I'm back with, could you introduce yourself?
Yeah, I'm Andrea Silva with the Case Western Reserve University rocket team.
Awesome. And what's your role in the team?
So I'm an aerostructures engineer as well as the PR manager.
Awesome. And you've been telling me that you've been trying, well, your team has been trying to launch since Wednesday. What can you tell me about that journey?
Yeah, so we initially came to this competition very well prepared. We're in the 30K COTS category, so we came to this competition on Wednesday, ready to go, but unfortunately due to the wind, we had a lot of difficulties launching, and they eventually, by the end of the day, scrubbed the rest of the launches. So we waited till Thursday, ready to go, bright and early on Thursday, and then we had some difficulties on Thursday. When we got to the launch pad, we had our rocket, and we were trying to put our igniter in, and then all of a sudden, a big gust of wind came and knocked our rocket, knocked the launch rail over, and with our rocket on it. So we had to deal with a lot of difficulties in terms of fixing the rocket, but people here from Tripoli, ESRA, they've been very cooperative in trying to get us to launch today. So we took all of yesterday to really prepare our rocket to make it the best it can be, quality over speed, and now we're here today and very excited and very confident of our abilities to launch this rocket today.
Awesome. Would you say that that has been like the biggest hurdle you guys have had to face?
So initially, we had a couple of other hurdles as well. So Case Western's from Cleveland, Ohio, so we had a couple difficulties in terms of test launching our rocket due to the weather. In the spring, it's very, very troublesome. So that was initially probably our most difficult hurdle to jump through for this competition, but then as soon as we got here, I think the wind conditions has probably been our biggest enemy going into this competition. But I think I would say our leadership has been very, very strong, and then our team culture as well has been incredibly admirable. So I think we've been able to make the most of this competition and have a tremendous week here.
Awesome. Is your whole team here with you guys, or are you guys missing some people?
So we have most of our team here. We have a couple of folks back home definitely cheering us on, watching the live stream. But I would say that it's been a fantastic time having most of our team here, definitely more people than we came with last year. All hands on deck, and it's been a great time.
So you guys were here last year. How many times have you guys been to this competition or participated in it?
So this is technically our third year. The first year that was kind of the virtual competition. That was our first year competing in Spaceport America Cup, and then we came last year, competed in the 10K COTS category, and actually won that category, got second overall in the entire competition. So we decided this year, why don't we take it to the next level? So we are competing in 30K COTS, and that in itself has had some of its own difficulties with design going from, 20,000 more feet, but it's been a fantastic time figuring out all those things as a team.
Cool. Well, thank you for being here with me and describing your journey. It's totally been a rocky one. Hopefully you guys could launch today, and thank you for being here with me.
Thank you so much.
In at a place we haven't been to before, over on the hybrid rails. What's going on here? You got like bottles and stuff next to this thing.
Yes, sir. So I'm Chris Maier. This is Drew Nichol.
Hi. I'm the current safety lead for Ezra. So basically we coordinate with the teams. Hybrids have a lot going on. You may have seen the solid pads where the teams will walk their rockets out to the pad and launch them. For hybrids, we have our own little space, and we basically live here the entire week.
Yeah, so hybrids is complex, right? And people don't appreciate all of the extra infrastructure that goes into a hybrid. First thing is, like, what is a hybrid, right? So you're used to a solid rocket motor. It's pretty simple. It's, solid fuel. Liquid rocket motors are, more like the NASA complex liquids in pressurized tanks. And out here, they have kind of a combination of the two. They have a solid grain, and they have a typically nitrous, right?
Yeah, it's normally nitrous oxide. For this competition, we follow Tripoli rules, so the only oxidizer we're allowed to use is nitrous oxide. Some professional companies have experimented with other oxidizers like liquid oxygen, high test peroxide.
Okay, so yeah, so under Tripoli we're using nitrous, and that's what the bottles are, right?
Yep.
We see the bottle here. keeping heat off of it. There's pressure sensitivities when the heat goes up.
I can get closer, right? Yeah.
Oh, absolutely.
Let's have a look at what makes these so much different than just a couple alligator clips and an igniter.
Yes. So they've got fill valves. They've got a very complex system to get the liquid in. Now, they don't put any nitrous in these until everybody's evacuated the area, right? You can actually see the student-developed ground control system. It's under the heat blanket. A lot of times these kids are out here building electronics with Raspberry Pis and other things, and they don't anticipate the heat and other challenges associated with that. So these guys have a lot more complexity to deal with to fly their rockets. And this is why you see so many hybrid challenges, right? This is why the hybrids end up taking a lot of time to get to the point where they're ready to fly. Everybody has to evacuate. They start a fill process. They have to know that they're full, and then they can actually start the rocket launch.
So like yesterday, I was out at the solid rails, right?
Yep.
And when you're setting up the solid rails, there's the box there where they were checking the continuity, and that's already set up for them.
Correct.
So,
that's infrastructure provided. And that is not the case with the hybrids. This infrastructure is typically custom to each and every team and each and every student, right? This is the UTSA team. I'm actually the flyer of record and mentor for these guys, so I've been helping them with a whole bunch of things. You also notice that the rails out here for all these hybrids are much longer. Hybrid rockets tend to have a much lower thrust to weight ratio, and therefore they need a lot more rail to be able to get the rocket stable before it leaves the pad.
I think I said runway earlier. It's almost like the rocket's runway. The rail is something that's giving it control, stability until it's free flying on its own.
Yes.
So lower thrust to weight, it needs to accelerate more and it needs to be, I guess, in control. You need to have that stability until it leaves the end of the rail. Plus, this doesn't look like anything like the rails out there at the solid site.
No, they also all pretty much build their own rails. Some of them build them on a trailer and bring it like that. Some of them bring parts and erect a rail fixed to the ground. They're all tall enough that they have guy wires and support up at the top, staked to the ground. There's a lot that goes into this hybrid. They have to bring the tanks out here, right? We have to arrange for tanks to be delivered so that they have nitrous oxide for the launch. That's about as much as I know about that. You probably know a whole lot more about how they get this nitrous out here in that whole process.
Yeah. So for this competition, we've sort of partnered with a couple of local gas suppliers. So you have Air Gas, you have Lindy. In the past we've used Praxair, but about a month out from competition, students will have to place orders for their nitrous and other gases. Some teams need CO2 for cooling bottles. But with these systems, depending on how they are controlling valves or how they are lighting the propellant, how they stage the motor startup, every single system is made specific to that rocket. And
From the commentary booth, we have a member of Team 13. If you'd like to introduce yourself.
Yeah, I'm Andrea Silva with the Case Western Reserve rocket team.
All right, so what are we looking at here?
So our rocket is a 30K COTS. Yeah, so our rocket is a 30K COTS category rocket. It's had a lot of adjustments in the past couple days. So originally we were flying on an O 3400 motor, and now we're flying on an N 1450. So it'll be going max speed around Mach 1.1. This rocket is pretty short for a 30K COTS rocket, but it's got an excellent paint job, and we're very confident about how it's going to launch today. Spaceport has given us a lot of challenges throughout this week, but overall we've had a fantastic time and have been able to work really well as a team throughout these challenges.
N2 ready?
We would like to thank all our sponsors, our friends and family back home that are watching this launch. We couldn't do it without them, and we're so happy to see this rocket fly finally.
So now that we just saw the rocket fly, how do you think the flight went?
Overall, it kind of went at a bit of an angle. That could be attributed to a couple things, maybe a little bit more wind. We had a little bit of issues on Thursday when our rocket fell off the launch rail with our fins, so that could have caused a little bit of instability.
Yeah. Great. Thanks so much for joining us for your launch in the control room.
Thank you so much.
It's not just the same wind all the way up. No. It varies significantly.
The smoke tells you the story of the wind.
Look at that.
Moving on to pad Alpha 2. Alpha 2. This is team 149 from the Vellore Institute of Technology, Vellore in India. This is their rocket, Mara, 65 inches tall, 4.5-inch diameter, 36 pounds, flying on a COTS M2050 motor. They're expecting 9,900 feet at Mach 0.86. They hope to accomplish their first launch and to test their SRAD flight computer. are green on Alpha 2. Range is clear and skies are good. We are launching in 5, 4, 3, 2, 1. We have liftoff. We're moving to Bravo 1. Bravo 1. Team 6. The Bandirma, Onyedi, Eylul University in Turkey, flying their rocket Marmara 6. This is a 108-inch tall rocket, 5.1-inch diameter, 65 pounds, flying a COTS M2022 motor, expecting 9,900 feet at Mach 0.83. And these are universities located around the Sea of Marmara, Turkey. We are green on Bravo 1. Clear range, clear skies. Launching in 5, 4, 3, 2, 1. Out on that rocket, both chutes are out.
At the Kansas City National Security Campus, our work is more than a job. It's a mission to deter our adversaries and assure our allies. Since our start in 1949, we have seen dramatic changes in our business, our country, and our world. But one thing has never changed: our unwavering commitment to the mission. Our mission defines our past and guides our future. We have a proud history supporting the nation's warfighter. Our brothers and sisters in the Air Force and Navy bravely put their lives on the line every day. That's why we put our best foot forward, making sure the nation's nuclear stockpile is safe, secure, reliable, and effective every day. It's more than a job. It's a passion and a partnership across the National Nuclear Security Administration and its 8 national security labs and sites to support the nuclear deterrent strategy and ensure our country is prepared to defend our freedom. It's why we have a relentless pursuit of perfection and exacting standards of quality. Our superior performance is reflected in our work and measured in our dedication. Our world-class team of engineers, scientists, and technicians employ innovative, high-tech solutions and develop new and emerging technologies like digital manufacturing, simulation, and augmented reality to solve complex nuclear security challenges. For 70 years, the NMSA and Honeywell have worked together to protect our country. Today, we are stronger, faster, smarter, and more focused on our mission because we do work that matters. At the Kansas City National Security Campus, we are the mission. Our mission is to support the warfighter and keep our nation's nuclear stockpiles safe, secure, reliable, and effective now and always.
Right here, still zip tied down, but bottle valve will basically controls the flow of the nitrous out of the bottle. To start with opening the bottle valve will pressurize all the way up to this tank valve here.
Happening out on the hybrid pad.
This is our filling valve. This is what controls the flow of nitrous in and out of the motor itself. So once we're good, we're going to start filling. We close this valve here. This is our vent valve. I think Drew was talking earlier about how we need to have a system to abort nitrous or dump nitrous in the event of us having to stop. We don't want to come out here when there's pressurized pressure vessels because that's just a safety hazard for obvious reasons. So we close this vent valve here. We open the tank valve. Flow starts flowing up and around and in from the bottom to our motor here up through this fill stem. Starts filling the tank, starts filling slowly. The tank is about here-ish, right? And you can't see it, and so it's a little hard to describe, but there's a small, similar to the dipstick, it's like a reverse dipstick. There's a vent tube that runs all the way to the top of the tank, and when the liquid reaches that tube, it starts flowing back down the tube and out this little vent hole here. Once this little vent hole starts spewing not gas, but actual like vaporous nitrous, we know we're pretty much full. We're ready to go. We go ahead and turn off the fill valve, and then we run our auto ignition program, which will do a couple of things. One, after 3 seconds, it disables all pins and safes the system, right, in the event that there's not an ignition. But two, before that, there's a small dual-headed igniter in there that will ignite, and there's some leaking nitrous coming out, just a little bit of leaking nitrous from that O-ring seal that this guy plugs. It reacts with that leaking nitrous. It gasifies the solid wall of the solid fuel grain for the ABS. That preliminary little bit of fire comes down here and burns away this strap. Once this strap burns away, this entire apparatus, the fill stem, drops out, unseating the O-ring and allowing the nitrous to flow through the injector into the hopefully on-fire combustion chamber, really kicking on the gas and sending it.
All right, so there you have it. That is how a hybrid works. And as you can tell, it's a much more complex process, even with ignition and everything. He mentioned that the fuel grain here is ABS. It's like a plastic. I think a lot of other folks also use paraffin wax. I don't know. Is there anything else that they typically use as a fuel grain?
I'm trying to. There's a I'm trying to think. There's another thermoplastics, basically, like thermoplastics that you can really use anything as a fuel grade. I know Peter was talking about he made a hybrid out of salami once, right? You can, if it has carbon in it, you can send fire through it, an oxidizer, and it'll burn, right? The reason we obviously go for thermoplastics is because they have a higher energy density than grocery store salami.
Gotcha.
So a real quick question. You talked about the valves and stuff over here, but those are not valves that have handles or anything on it, right? You're not here actually turning valves open. That's all has to be remote operated, correct?
No, yeah, you are absolutely correct. I don't want to be the guy out here turning those valves. That would be a fun day for the insurance company. So instead, the way we control that is through our GSE down here, Ground Support Electronics. If you look at about midway up the tower, you'll see a white box. That is our wireless TP-Link that allows us to communicate with our mission control. That's 1,500 some odd feet down a ways down the road. We're able to send commands wirelessly to this system using this box, be able to actuate those electronic solenoid valves pretty rapidly. Right now, we've been having a few issues with our connectivity, but nothing show-stopping yet. So, hopefully everything goes well up until launch.
So even that you had to make yourself. I mean, there's not a wire that you plug into out here for IP connectivity. Like, you had to rig up the point-to-point link to send commands to your custom GSE to remotely control all of your valves so that you can fill up the rocket, and all that's on you.
Yeah, well, so the joke this year has been the rocket is the easy part, right? We've done some high-powered rockets before, and some ones that are definitely a lot more complicated than this. The big push this year has been all of this ground support, the trailer, the launch rail, the ground support electronics, the plumbing, all of that. We've done this in a year, right? Along with the rocket as well, right? And we're only back in San Antonio, we maybe only have about 12, 15 people working on this, right? Yeah. So we're definitely on the smaller side of the team, but I'm really happy with the progress we've made in getting all this thrown together this year.
Awesome. I think that's one of the things that people just don't understand with the hybrids. They're like, what takes the hybrid so long? Oh, you have to worry about the temperatures and pressures, whatever. It's not just that. It's like the entire system is all yours. It's not just that part of it's a liquid or gas or whatever and the other part's a solid. All your infrastructure is part of the design.
Yeah, it is not just as simple as pressing a button, right?
Yep. A provided button, even.
Yeah, exactly, right.
The button.
We have to make the button, and then some.
If you'd like to launch a hybrid first, you have to make a trailer. Not actually, I guess.
Yeah.
At least the rail and all the other system that you have to have. Have you had trouble with heating? I mean, I noticed all of the thermal blanketing and that sort of stuff out here.
Yeah, so the first time we came out here to launch, we kept losing conductivity because the Pi was overheating really badly. As you can see, it's hard to tell, but underneath the box itself, there's a bag of ice.
Oh, really?
Bag of ice. We got the space bag over it. We got, a lot of different systems keeping that cool. And even then, it's still getting a little warm, so we have it all powered off right now. Just let it relax, cool down a bit. Yeah, that's kind of been one of the issues we've been running into. Once we got that working, then we had some issues with the avionics. This is playing like engineering whack-a-mole here. One problem solved, another crops up.
What's the next one? Yeah.
Yeah, hopefully we don't have any problems today, or at least if they are, they're minimal. I'm honestly feeling really good about today, so we'll see what happens.
Nice. If you want to turn your PoE injector for your TP-Link there, I can show you the part on Amazon that's the right voltage. This is just DC.
Oh, really?
Yeah, we use those all over Starbase, all of our stuff.
That would be really nice.
We were having to invert from AC to data, and we finally found this stupid little dumb PoE injector.
That would be super. That would be super sweet. I really
you lose less going back and forth.
Yeah, we've been struggling trying to figure out all right, what do we got to put in here to make it work?
Yep. I mean, the things that you're solving here are some of the same sorts of things that we solve at Starbase with all of our remote camera systems. That box is even exactly like some of our original boxes.
Really?
Yeah, it's the exact. It's probably a different brand because there's like 15 brand names that are all the same exact box that they resell.
Yeah.
But what you've done there is very, very similar to what we solve for like the 24/7 SIN systems out of Starbase. And overheating, that's a thing.
I'd imagine down in South Texas. I was there at Dover in March when we did the Starship launch.
Yep, nice.
That it was getting pretty hot down there.
It's so hot. But you got your air gap already, right? You have your reflective surface, your circuit, and it's not actually hitting your box itself. So you have air flowing between. You leave the box open?
We're gonna
leave the box open.
It needs to work once.
It needs to work one time this year.
Yeah.
Excellent. You even put the ice underneath it. That's crazy. I saw this earlier. Whose brainchild was honk for rockets?
That was our boy Jacob over here.
Where's Jacob?
We have Jacob.
Uh-oh. Is there more? This is like the space shuttle, like black side down, right?
We have a hydrate sticker.
Hydrate sticker. What does this say?
If for no other reason than to outlive your enemies. So we kept this magnet on from the entire way from San Antonio, and it didn't fall off.
It didn't fall off.
It's our good luck charm.
Good luck charm. Nice.
So yeah, there we go.
Excellent. Anything else? I mean, this is just crazy. I think this is the thing that people don't understand. It's not just go out and put it on the rail that's provided and press the button that's provided. It's not just engineering your rocket. Like you said, the rocket is the easy part, right? I think that's what you said, right?
Yeah. For this, in this case, yes,
in this case, the rocket's the easy part.
Right.
And all the other things to remotely control it, do it in a safe manner, because I've been out here when somebody couldn't drain their rocket, and they lost telemetry or control or whatever, and so the rocket's sitting there and it's full up, and it's heating up, and the pressures are increasing, and, well, I don't think I'm supposed to repeat how we vented that tank, but whatever.
Yeah. Old Yeller.
Yeah. Old Yeller tank. Nice. Anything else that I missed about?
I don't know. I can't think of anything. This is pretty thorough coverage. Anything you?
Last minute. I'm about to start setting up some cameras to start testing, and then I think we'll be good to go. I think we're going to. Oh, we're at yellow flag right now. Yeah, I'm gonna go ahead and start setting up and getting things ready to go.
Awesome. Thank you so much for the time. Thanks for running us through your systems.
No problem.
Nice. Good luck, y'all.
We're out.
The end.
Okay, good morning, Spaceport America Cup. This is Ezra President Cliff Olmsted. Happy to be with you on the live stream this morning. I'm really pleased to see we got a few rockets up so far on the solids pads. We're standing by on the hybrids. I know we just did an interview out there, and we're getting those teams ready. The last teams available to fly are the ones we've got out there now. Our flight window closes at noon Mountain Time, so the clock is ticking. We're just coming up on 9 a.m. here, so about 3 hours left for flight. Also, on the live stream, it looks like there's a traffic jam with a water truck and, I don't know, some other truck turning around. I can't tell who that is. It looks like they're working it, but I know there's a lot of water coming out of the water truck, and there was quite a bit of interest. So Andy was having quite a lot of fun explaining all the details that go into the delivery of water on the roads. But you can see the change in color, and man, it sure does keep the dust down. Really great to see. Our teams that launched so far had good flights overall. I think one came down ballistically with no parachute, but the rest, at least to my eye, looked like they came down in pretty good shape, so that's great news. I also heard our team from South Korea flew, and so really glad to see, especially our teams that have traveled so far with us, to be with us, get up in the air, even if it pushes out to the very last day. The other challenge is recovery. I mentioned this yesterday. So Saturday is our final day of flight. Our flight window ends at noon. Also, our judges have to depart for final deliberations and compilation of all the scoring contents at noon. That means teams who recover or head out to recover their rockets need to get those rockets back. They need to get them to the recovery area for the post-flight check-in and assessment. They also get their final barometric score data so that we can enter that into the scoring sheet and get that all factored in. Once the judges depart, we really don't have an opportunity after that to take last-minute scores. That's just one of the unfortunate logistic elements of the way the Cup happens, and over the course of the weekend, we can't just continue to collect data and adjust scores because we've got trophies to announce tonight, so I hope you'll tune in at our award ceremony. It's really going to be nice. We uncrated the official Genesis Cup, Spaceport America Cup Grand Prize trophy, and it looks, pardon the pun, stellar. So really nice. Look at that water truck go. Meanwhile, we can hop up to the LCO area, and people are just kind of standing by right now. I don't have any rockets currently standing by for imminent launch. I know our hybrid pads went to yellow, so they're getting ready. We've got no other solids on the pads in the moment. The solids pads are green flag. Green flag, remember, is the availability for anybody to head out there and start getting their rocket ready. Once those rockets are prepared or getting loaded and igniters installed, we'll go yellow flag, and once they're ready for launch, we'll go to red flag. So we're still on green flag, standing by for any last solids. I walked around our base camp area, and looks like there's a few teams still doing some mad scrambles to get their rockets ready. So hopefully they only have some minor things to do, and then they can get through the safety reviews, but final safety reviews and checks before they get out to the pads. But that can take a while, so hopefully they're moving carefully and efficiently and can do that. You can see in the aerial view, the water truck has just returned past our camp here and is heading down the way through the rest of camp to get the roads wet. And if we pan up on that view, you can see the ability, or the Da Vinci tent in the back, and also to the left of that Da Vinci tent is where the safety reviews occur. Let's see if we can get a view of that. Oh, they're coming in for a recharge on battery, so that's all right. We'll get some other views and we'll come back to that. When we get a chance, we'll try to get you a view of base camp, and maybe we can see what teams we have that are still doing their final preps. The good news is this morning the winds are fairly calm. I haven't pulled up the official wind status, but just standing out there, it's quite nice. It's a pleasant 75 degrees Fahrenheit, warming up quickly. And with luck, we'll be able to keep our winds low to get all these last rockets that are available for launch up in the air before our noon cutoff. Nice haze in the background. You can see those mountains, the rugged terrain. It's really flat right here for the most part. There's a few rolling hills, but boy, you go just a few miles out in the distance there, and it is very, very rugged mountainous terrain. All right, back to the hybrids pads. Team's still getting ready. Rockets on the rails. Although I think they've been on the rails for quite some time, so they're just going through all the technical aspects for hybrids. I know Team AGH from Poland had to scrub their launch from yesterday because of the winds. So I'm very hopeful that today they can do their final checks and get going. Even with an early morning start, there's still a lot of technical aspects and preparation that is required to get hybrids ready for fill, and we can go red flag on hybrids. So standing by on that front. All right, transitioning over to our safety inspection. This is the final inspection prior to being authorized with a flight card to go out to the queue and head out to the pads. Not sure which team we're looking at right here, but you can see Rocket Yoda is doing his work already, walking the team through his checks and letting them know if there's any remediations they need to do before they get the final okay. Process sometimes takes a while, and sometimes teams have to come back and forth several times. Again, it all depends on preparedness. The best teams arrive at Spaceport America with their rocket already in great shape. They've done all the work prior to arriving to ensure that the rocket is stable, is constructed well, that fins are attached very securely, that the join sections for the rockets don't have any play, but also are loose enough to be able to eject the parachute correctly. And when they can do all of those checks before they get here, that puts them in a much better position so that they can show up, walk us through their safety inspection prior to arriving here at the VLA, and then head out, and Harry there will do his final check, and it's a smooth sailing process. can't tell for sure, but it looks like he's handing the flight card to them. And he's pointing them over that way, so I'm going to guess that that team is ready to go. But that's only a guess. Sometimes there are some things that they put on the flight card I can't tell necessarily from here. I see another rocket in the background at the safety check-in. That's a good sign. I want to get all the teams that have not been up through their inspection process to get them going. Already 6 minutes past 9. I feel like I've been talking for about 30 seconds. Time moves very quickly when you're in a mad preparation for getting these rockets taken care of. So there they go. Let's see if the second team behind them will pick their rocket up and bring it on the table for our Yoda master to do his inspections. Okay, back out at solids pads now. I see one rocket on the rail, another team carrying their rocket to get prepped. The team that just left the safety inspection area may be provided an opportunity to get on a rail here now. There's a couple more rockets. Excellent. So for my information here, it looks like we've got 1, 2, 3, 4, 5 teams on the solids rails getting ready. Let's walk through them. Team 67 is New York University Abu Dhabi. That's from the United Arab Emirates. Their rocket name is Halo Ship. Rocket is 114 inches long, 6-inch diameter, 60-pound rocket. That has a COTS M1450 solid motor. They're expecting 6,000 feet at Mach 0.6, which is interesting because our target is 10,000 feet minimum. Let's look at some of the other teams. We got Team 143. Getting my data here. So Team 143, University of Utah. Their rocket is U of UFO. Very nice. 101 inches long, 6-inch diameter, 52-pound rocket with a COTS M2320 solid. They're expecting 10,192 feet at Mach 0.86. Up next is Team 146, University of Windsor in Canada. The rocket name is the Windsor, 139-inch long, 5.7-inch diameter. That's an 86-pound rocket with a COTS O motor. It's a O3417. They are expecting 25,000 feet at Mach 1.5. And we'll go ahead and switch over now to an interview with, looks like, Monash University. And we'll be looking forward to see what they've got to say.
Good morning, you guys. I am here with Isaac, who we've previously interviewed, but we just found out that he's trying to take as many pictures with as many teams as possible. So, Isaac, what inspired this project?
Well, I guess it was something I thought about a few weeks before coming to the competition. I've been reflecting on the competition. I came last year. It was really great, but for me, I was team lead last year. It was a really stressful time. I know I was flat out, and I know that's the case for a lot of people on a lot of teams. But what it meant was that I didn't get the benefit of coming together with lots of people in the way that this competition is actually really beautiful for. We've got so many international teams and so many great American teams as well. And so I was thinking about what is the best way to greet as many of the teams going around and learn about what they're doing and learn a little bit about them as possible to really get the most out of the sheer number and kind of diversity of people at this competition. And then I thought, well, a great conversation starter is, hey, can I get a picture with you? And then I thought, well, it is a competition, so I should set a performance goal. So my kind of performance goal was try and get a photo with someone from every team in the competition. So that was the idea, and I'd kind of hyped it with my team coming into the competition. We talked a lot about it, and then on the first day, like the sign-in day, my social battery was so low, and I couldn't. I took one photo with Teo from Oranus Polytechnic, and then that was it, man. I couldn't do any more. I couldn't do that approach. It's a really tough thing. And all through the poster day, kind of the same. Actually, on the poster day, I spent my time watching all the podium sessions. I'm a bit of a sucker for nitty-gritty technical, and so I didn't have the time. But then the first launch day rolled around, and our team were just in go mode. I didn't need to be around that. They were on fire. So I grabbed Jade, who's our business lead, and she was on the camera the whole time doing an awesome job. And I went from the front end, so starting at team 1, which I think is AGH, and worked down, and then up, and then down, and then up, and hey, my name's Isaac, I'm trying to get a photo with someone from every team, can you help me out? And look, people were so open to it. Yeah.
And how's it going so far? Have you got in every team?
We got about 85 as of the second launch day, and so I've put the onus onto anyone who I haven't taken a picture with to come and find me now. I brought this list with me, and you can see it lasted as long as exactly one greeting. Teo from Oranus Polytechnic. And then I completely forgot it was in my pocket for the rest of the time. So I don't have a good record. All we have is the photos. We've got the wall, like a montage of all the pictures up on our Facebook page. So if you go to Monash HPR's Facebook page and check it out, and if you can't find yourself there, please come and find me. I'm here at the VLA all day helping pack down, and then obviously back at the presentation night as well. So we'll see you there. And I'd really be honoured to take your picture if we haven't done it together already.
And you mentioned that you're posting them on Facebook. Are you wanting to do anything else, like a video montage, or?
We might do a little bit of a video montage. We'll see. That's out of my domain. I'm here to generate the content, and then they'll go and do their thing. We have an awesome business team. You can check out any of our socials and see they're so on fire. I'm really impressed and proud of them.
Awesome. And what does it mean to you to be in this competition and having the opportunity to talk to so many people?
Oh, this is amazing. The biggest thing here, there's so many great things about this competition, not only when it comes to the technical side and getting to learn what other people's approaches are to the same problems that I have back at home when I'm working on my motor or whatever it is, or my rocket, but also their approaches to engineering in general, and just the awesome opportunity to socialise with like-minded people, kind of my age, who are into rockets, who do spend hours and hours every week in at their workshop or on their computer, doing the same hard yards, and it's not an environment that you're exposed to all the time, because we're a tight-knit group, and outside of that bubble at university, not so many people are dedicated to that. So here is just an awesome space full of people that are so keen for rockets and so open and giving with their technical expertise. It's truly amazing.
Awesome. Is there anything else you would like to add? Maybe plug your socials one more time so people can go see the pictures?
Yeah, you can find us. You just search Monash HPR on any of your social platforms. Even if you are a true networker and you're on LinkedIn, we're there too. So come and find us on any of those platforms and chuck us a like as well.
All right. Well, thank you, Isaac. We're going to get a picture with him too so we can be included in the photo montage. And do you want to do it right now? Okay.
We can do it now.
We'll do it right now. So you know that we actually did it.
There we go.
Oh, with him.
Oh, yeah,
with the camera.
Of course.
Even the live stream is going to be in it.
So everyone watching along at home on the live stream, you're taking a photo with me as well. There we go.
Awesome. Well, thank you, Isaac.
Isaac, show the camera that picture.
Okay, yep. I'll get the picture for the camera.
Show the beautiful faces. Show the live stream.
You want some brightness? Oh, that's all I've got. We'll send it to you.
All right. Well, we're hoping to see ourselves in the montage soon. Thank you so much for speaking to us.
No, it's a pleasure.
And we'll go back to you guys.
Okay, welcome back. While that interview was happening, updated news, hybrid pads are going red flag, which is very exciting. So they are sorting out which teams are going to go first. There's different fill times and different requirements depending on the details of each individual rocket. So once I know who's flying when, I'll certainly let you know. We'll keep a close eye on that. It takes some time to fill, and we'll come back to you when we got all that information. Meanwhile, on the solid pads, we're continuing to load our teams. We're still sitting at, according to my information, 5 teams altogether. They are green flag to the best of my knowledge at this point, so waiting for those last teams to get out there and complete their reviews and hopefully get out to the pads for this salvo. Some amazing radio sounds this morning. Okay, there's our view from the hybrids pads.
LCO, this is hybrids. Team 142, University of Texas, San Antonio is going to commence filling.
Okay, so there's the call. Team 142, University of Texas at San Antonio. They are commencing filling at the hybrid pads. Rocket name is Linda.
Start Wroclaw and AGH.
Also, we've got AGH, University of Science and Technology from Poland. Their rocket name is 3TTK+. And Wroclaw University, also from Poland. That's the University of Science and Technology. Their rocket name is Aurora. That's 3 hybrids that are getting imminently ready for some launch attempts. Winds are still calm. It's 20 after 9. Tick-tock, tick-tock. Great aerial view. Again, fill time takes a while, so we're just waiting for confirmation that the fill is complete, and then they'll be ready for their launch attempts. We'll keep you updated as those radio calls come in, and we have updated status.
Just to confirm, AGH can start filling? Yes. He is starting fill.
Okay, Team AGH is starting fill. Solids are also going red flag. Excellent news. Excellent news across the board. That means we have hybrid pads and solid pads red. That's what I like to hear, especially in the morning. We're watching for the status of our hybrids and our solids, and I'll let you know which rockets are going next as we find out ourselves. All right, another 8 to 10 minutes. That'll put us at approximately 9:30 local time for the fill. On the solid sides, other teams that are getting close to ready, the University of Houston with their rocket Shasta 6. It's a 67-pound O motor rocket. And also Team 146, University of Windsor in Canada. That rocket is the Excalibur. 108 inches long, 72-pound M motor. They're expecting 10,487 feet at Mach 0.75. And lastly, Sakarya, University of Applied Sciences in Turkey. Their rocket name is SUBU. We'll call it Subu Tech Cord 2023 with an M motor. 10,016 feet is their predicted apogee at Mach 0.8. So we're waiting to get the pad assignment sorted out for them. We'll keep you posted. And we're just waiting for the next approximately 7 to 8 minutes for fill to complete on one of our teams out there.
Yeah, I should have clarified. In the control room, we have a flight radio. The rest of the staff does not.
Halfway through the fill on UT San Antonio.
University of Texas at San Antonio is now halfway through the fill.
It looks like we're halfway through the fill on Team 142 UTSA, so we're looking at launch in 5 minutes or possibly less.
We're standing by Team 18, Columbia University in the city of New York. Their rocket name is 30K Final. Just waiting for updated status on all these teams. All right, that's the team at University of Texas San Antonio. All crowded around their control panel, I'm guessing, and looking for telemetry. Another 5 minutes here. Yep, back of the vehicle. Everybody's crowded around, waiting to get their status. Hearing another approximately a minute.
Down to 1 or 2 minutes on 142.
For Team 142, University of Texas San Antonio.
Everybody ready and watching out at the hybrid pads for University of Texas San Antonio, Team 142. Flying Linda, 156-inch tall rocket, 6.2 diameter, 65.5 pounds. It's on a commercial M1006 hybrid, expecting 10,000 feet at Mach 0.65.
University of Texas at San Antonio is a commercial off-the-shelf hybrid motor. If I didn't say it before, they're expecting 10,064 feet at Mach 0.65. This is the hybrid propulsion project for the 10K COTS division of Spaceport America Cup. Team is looking for confirmation of fill status and other telemetry. Once they give the signal, they'll signal back to our launch control officer, and they actually control the countdown from their location because each hybrid rocket has its own custom design and built ground support system that includes launch control. So they will relay their countdown back to launch control officer. Okay, here we go. Team 142 is ready for countdown. Fill complete. Standing by.
Here we go. We're launching in 5,
4, 3, 2, 1. Okay, they're holding down the launch button. Sometimes these take time to ignite and get into the air. Can sometimes take up to 30 seconds. Looking for signs of progress. Fingers are crossed. Still holding that launch down. Okay, they're going to do another attempt.
They're going to need a new igniter. We will update when we have more information.
No luck. Well, unfortunately, Team 142 had a misfire, so they're going to have to detank their nitrous. Hopefully they can recycle for another attempt today.
142 is detanking with the misfire. Next up on hybrids, when they finish their fill, is Team 18, Columbia University in the city of New York.
Okay, so we're going to attempt now for Team 18. Team 18, Columbia University. I see you on the chat. Columbia University, City of New York. This is an SRAD O hybrid motor. Expecting 30,003 feet at Mach 1.89.
The nitrous paraffin wax fuel grain.
In their description, they say Columbia Rocketry is planning to field a completely redesigned nitrous oxide paraffin wax rocket at the Spaceport America Cup. Okay, so Columbia is filling. I hear that Team AGH, their fill is complete, but they're waiting to complete their pressurization. Just standing by to get these last moments of fill complete and the countdown to commence. perfect weather for a launch on hybrids this morning. Teams are out there at the hold point. Standing by. There's a shot from launch control. Again, red flag on solids and hybrids. As soon as I get information on which rockets are out on which pads for the solids, I'll tune in and give you that information. Right now, we're just waiting for fills to complete and pressurization to complete for Columbia University and for AGH, University of Science and Technology.
Onshape is excited to sponsor collegiate teams with donations of our cloud-native product design platform. Trusted in industry by companies like Trek and Form Labs, Onshape is a professional computer-aided design tool with product data management, simulation, and more, all built into one accessible platform. You can use Onshape to bring your team's ideas to life faster and more efficiently. Explore different builds, test your designs, communicate improvements, and do it all entirely online. No need to download or install. You can all work together in your Onshape document at the same time, from any device, anywhere, collaborating digitally in real time. Learn more about getting your team sponsored by Onshape by visiting us at onshape.com/edu.
We're going to build a road to space. What we know is that there are certain gates we have to go through certain prerequisites. If we don't do these, we will never get there.
First, we have to radically lower the cost of access to space.
This means reusable rockets. We need to get really, really good at using rockets over and over again.
Once you have low-cost access to space, the second gate becomes actually accessing the resources of the solar system.
Space resources. The moon is where we'll learn to do all this.
The moon has a vast quantity of resources.
And if we can learn to harness those resources, we can travel without stressing the Earth.
And last, one of the things that we have to do is inspire those future generations.
We have to inspire the next generation to carry this torch for the benefit of Earth.
For the benefit of Earth.
Okay, with you back live. Still at the LCO table there. We're standing by for latest information on fill and pressurization status. Both for Team AGH, that's Team 1, and Team 18, Columbia University, City of New York. You can see the winds are still quite calm, so we still have good weather conditions in the moment. Continuing to watch that. It's 9:37 local time. Okay, the latest word is AGH believes they're approximately 5 minutes away from being ready to go. We're waiting for status on Team 18, Columbia University. We're going to make a switch now over, and we'll get an interview while we wait with one of our other folks.
Good morning. We are back here in the studio with our table. It's back. And I am here with Josephine from the University of Houston.
Go Cougs!
How are you feeling today in the last day of Spaceport America Cup?
Oh, I'm feeling so many different emotions. I'm feeling excited, ecstatic, tired.
Have you guys launched already?
No, we're going to be launching soon.
Great. So tell us about your journey here and what's the experience been like?
It has been one heck of a roller coaster. We started off with a brand new 30K COTS rocket. So all year we've been just fundraising. We've been working on the design for the rocket. And in the past week, we faced so many hurdles. We never thought we'd get to this point.
What kind of hurdles did you guys face?
So one of our team members, we lost an entire car. His car broke down in the middle of, we were 1 hour away from Las Cruces, New Mexico. So we lost him. We lost 2 members from our team as well. They weren't able to come with us. So, you know, we had so many hurdles, but we're still here and we're still fighting.
Amazing. Well, I'm glad that you guys are still here. Well, that was a little bit sad. Yeah. What are you guys most proud of in your rocket and your journey here?
I think we're most proud of the payload team, sub-team. We have a really cool project in which we're going to be putting the flies to sleep, essentially. We're testing to see the genetic compatibility between, so flies are very genetically compatible with humans. I think it's between 60 to 75%. And we're going to be doing an experiment on them to see how they, what the G-forces affect them. And so it's pretty exciting, honestly. The judges made a joke that our rocket was like on life support because there's like tubes connected to it and everything. So it's pretty funny.
Cool. And how did you guys come up with the idea to include flies?
Well, we threw some theories around. We threw some ideas around in the beginning of the year. You know, what do we want to do for payload? Certain things like that. You know, like what's the best thing that we can do? What's something that's going to catch everyone's attention? And we thought, well, what else can we do but put flies in a rocket?
Yeah, I mean, it caught my attention. I've heard a bunch of other ones, but the flies is pretty interesting. What else can you tell me, like, about your rocket, and are there any other cool, unique features to it?
Yeah, so we actually have a tertiary SRAD flight computer. I think that's pretty cool. We also have a tip-to-tip layup of carbon fiber fins. I thought that was pretty interesting as well. So those are some of our unique features for our rocket.
Awesome. And What can you tell me, or is there anything else that you would like to add?
Just that we love Houston so much, and we want to say thank you to everyone who has helped us get this far, the alumni, professors who have helped us with equipment, with providing material science lab, things like that. Thank you so much, guys. We would not be here without y'all. Thank you for all of the money, the fundraising, your patience, and all of the experience that you've been able to help us out with. Thank you so much. We're so grateful.
Do you have people that you know are watching the live stream right now?
Yes, my mom and my girlfriend. I love you, Maddie. Thank you.
Well, shout out to them. Shout out to the people. Oh,
and Megan Thee Stallions
from Houston. Well, let's see what's going on outside. Thank you so much for being here with us.
Thank you so much for having me.
Okay, we're back. Just got word Team AGH is ready for ignition, so that was a perfect transition time.
I feel like it was all over the place. Thank you so much, guys.
University of Science and Technology in Poland. This is on 3 TTK rocket, 181
Okay.
inches tall, 6.3 diameter.
We're standing by for countdown on Team AGH.
On an SRAD N3676, 3766, expecting 10,300 Mach 0.83.
Their rocket, this is AGH University of Science and Technology in Poland, expecting 10,333 feet, Mach 0.83. Go AGH, stand by.
All right, we're giving them a 10 count. Here we are launching 10, 9, 8, 7,
6, 5, 4, 3, 2, 1. Okay. Waiting for ignition with a 14-second delay. Got start on their ignition sequence.
started. It will take them about 15 seconds to factory fire.
I see a little bit of fire. Ooh, we got liftoff.
We have liftoff. Away it goes.
Listen to that sound. All right, that is fantastic. Great job. Successful liftoff for Team AGH, especially after yesterday when they had to get taken down from the pads because of our wind conditions. Really excited to see them get in the air. Team 1-8 is approximately 2/3 full, so we're still waiting for the fill sequence to complete for Columbia University. All right, that's really good. So we had one scrub on the hybrid. We've got one successful launch. Team 142 had to scrub. They're going to recycle. Team 1, EGH, just launched. We're standing by for Team 18, Columbia University. And also Team 157, Wroclaw University of Science and Technology, also from Poland.
Up everyone, we have a call that it might be ballistic. That might be ballistic. Confirmation from hybrids.
Okay, AGH is on the ground. That's not a good sign. Doesn't sound like they maybe came down under parachute. But they did have a very successful launch, so really, really glad to see that. Hopefully they'll be able to recover their rocket and give us some status before the end of the cutoff time at 12 noon here. It's now 9:45. If you're watching live, you'll see how fast the time ticks by. All that careful planning, and when it comes to crunch time here, things move very, very quickly. So being prepared and being well practiced is just really key to being successful at this competition.
Can you confirm Team 1-8 Columbia is next, followed by 157? Columbia will be flying next, followed by Team 157 Wroclaw.
So we just heard that on the radio. Team 1-8, Team 18, Columbia University is next to fly. Next team after that will Team 157, Wroclaw University. Okay, we've got 3 rockets that will be firing on the solids pads. One team had trouble with their telemetry, so they will stand down this go. Waiting for final confirmation on the teams for the solid pads. I'm listening to the radio as I speak. On the solid side, University of Houston, New York University, Abu Dhabi, and University of Windsor, Canada are all on dock to fly next. The team 87, Sakarya University of Applied Sciences in Turkey, had to stand down for a telemetry issue, so we'll see if they can get turned around after this salvo of 3 solid rockets. That will also put the solid pads on the green flag conditions, which means any of our other teams that are struggling to get their final safety checks complete and get through the process might have an opportunity to get out on the next salvo. On the hybrid side, we're standing by for Team 18, Columbia University. Last I heard is they had 16 of 20 pounds of propellant to fill. Okay, Team 18, Columbia University, is at 19, at 1.9 out of 20 pounds. Team AGH did have a successful launch. They came down awfully quickly. I heard the rocket is on the ground, which doesn't sound like it bodes well for their parachute, unfortunately. But I hope that the team will be able to recover their rocket and at least give us their altitude data. We also score in the competition on the state of the rocket when it comes back to the ground. Obviously, if it comes in pieces and is not flyable again, then that's a significant element of the competition final score. We're looking for rockets that successfully complete their entire mission profile, from launch to the drogue at apogee and main at approximately 1,500 feet above the ground level, and then drift down to a nice gentle landing, and they can show us that the rocket is completely in one piece, as well as show the altitude data that they achieved. All that gets factored into the score. But the fact that they had a successful launch is really significant. The hybrids, as you are witnessing, are very, very challenging to get into the air. It's just a lot of work and an enormous effort by the teams. So all the folks that were involved in developing this motor, and again, Team AGH had a solid, this is a student research and development N-class hybrid motor, traveling at Mach 0.83. So the fact that they even get off the pad, frankly, is a huge accomplishment. And, we always want to see a rocket come down in one piece, but that's okay. There's lots to learn, and I'm sure that they are going to look at the results, and there's always design changes and tweaks, and, teams and students rotate over time, so it's different levels of experience that are acquired, and then once a student graduates, well, that experience goes with them. So you have a new team, and you've got to kind of figure out how you're going to continue the knowledge transfer and continue to build better and better rockets, and that's a challenge too. So it's all part of this competition, and we're just really happy that these international teams and students can visit with us and show us their passion and show us their efforts, and that leads to some success for them. So great, congratulations to Team AGH. So we are just standing by for Team 18 on Columbia University. I have not heard the latest status. Last I knew, they were at 19 out of 20 pounds filled, so I imagine they're pretty close. Some final checks for pressurization. And standing by at the ground control station. And once they've got final confirmation, then they'll commence the countdown and they'll let us know on the radio. Nice aerial view with our drone shot there. It looks like it's a static still screenshot, but those drones are so stable. It's really a great capability to be able to bring this and show you up close what's happening with the teams and be able to move those around. So. Okay, it sounds like there's some kind of hold. I didn't catch all the details. On dock, we are also standing by for Team 157, Wroclaw, University of Science and Technology. I have not heard an updated status on their fill cycle and what's happening with that team, so as soon as I find out, I will let you know. Okay, maybe stand corrected, so we're standing by for Team 18.
18 must be full because they're going for disconnect. We will be alert when we're ready for the 10 count, but it should be imminent.
Good news on Team 18. Columbia University is go for launch. Very exciting. I see you in chat, Columbia University. Let's do it.
We are launching in 10,
9, 8, 7, 6, 5, 4, 3, 2, 1.
Launch.
Commencing launch sequence. Looking for signs of life.
Correction. Holding for just a second.
Still don't see anything yet. It can take up to 30 seconds. Are they on hold? Oh. Okay. Never mind. They're on hold. Sorry. Sometimes it's hard to hear the radio comms while we're trying to multitask and watch the video stream too. Standing by. Okay, they're going to attempt again. That was a temporary hold.
Here we go. Launching in 10,
9, 8, 7, 6. Oh. Trying to get our count sorted out here.
Restart 10, 9, 8, 7, 6.
There you go. 5, 4, 3, 2, 1.
Launch.
I see smoke. And fire. And liftoff. Oh. A little heel to the side, but they are in the air.
It's outbound, but that's coming in hot. That is coming in hot. Heads up.
Okay, well, they did get into the air. It looks like they did, unfortunately, impact into the desert, but they did get off the rail. Team is really happy they got off the rail. I mean, you can clearly see some excitement there. That's great.
5 minutes into a 5-minute hold on team.
Obviously, some issues with the flight, but congratulations, team, to get out here and have that level of success, at least getting off the rail. So, all right, we'll find out what went wrong, but glad they had a flight. Very good. We'll move on. We're standing by for Team 157, Wroclaw University of Science and Technology. And we'll find out if Team 142, University of Texas at San Antonio, can recycle. Our window of opportunity for flight it's just coming up on 10 a.m. here. We've got 2 more hours before the flight window closes. We'll see what happens with that team.
Hey! That's amazing! Hey, you guys, come here. Let's go into a 10. Recovery team is going to need more than that. Like 6 hours. 1 mile. We're going to cover all the pieces, alright? I want every goddamn piece.
Okay, we're standing by on Team 157.
7 inches tall, 6.7 inches diameter, 69 pounds. This is an SRAD N1500 flying to 13,200 at Mach 0.82. And Wroclaw says we are a science association from the university founded in 2017. The aim of our project is to design, build, and operate sounding rockets.
Some information on the Wroclaw University rocket. That's Rocket Aurora. I mentioned that before. This is a student research and development N1500 hybrid motor. They're expecting 13,200 feet at Mach 0.82. As they added in the notes here, they say, we are a science association from the Wroclaw University of Science and Technology, Poland, that founded in 2017. The aim of their project is to design, build, and operate sounding rockets. So they're here. They've traveled far. We're optimistic that they will have a successful launch here. We'll find out any information there if they potentially aborted. We're standing by also on the solids pads. There's some rockets that are being loaded there as we have those last teams that get through the process.
morning. We are moving over to solids.
Team 157 has aborted their launch. We are now moving to the solids pad.
Right. We are starting solids on bank Charlie 3. This is team 122. University of Houston, rocket Shasta 6. 125-inch tall rocket, 4 inches in diameter, 66.9 pounds. This is on a COTS O 3400 motor. We're expecting 27,700 at Mach 1.72. Shasta 6 is Space City Rocketry's second ever 30K COTS rocket, and will test the viability of therapeutic hypothermia on fruit flies in a high-stress environment. We are green on Charlie 3. Skies are clear. We are launching in 5, 4, 3, 2, 1. We have liftoff.
There we go. That's a solid. Sorry, I had to step out of the room for just a moment to answer some quick questions. And I lost my toll train, so that's good. Okay, so we're looking at now on the solids pads, team 67, New York University, Abu Dhabi, in the United Arab Emirates. Their description of the rocket, the title is Halo Ship. It says Halo Ship is a rocket that is fully mechanical and reusable in its subsystems, built with no epoxy glue or any external screws. It packs into a suitcase and features a fully redundant and mechanical release system. I have not seen the suitcase. I imagine it's not a briefcase. Looking for a successful flight. This is a COTS M1450 solid motor.
On confirmation that it is coming down in a safe area. Next up on Alpha 1 will be Team 67, New York University, Abu Dhabi in the United Arab Emirates. That's Team 67 on bank Alpha 1.
Nice drone shot view. Standing by for countdown on our next rocket. Okay, not getting any telemetry data on Team 122, University of Houston.
Now moving to Alpha 1, New York University, Abu Dhabi in the United Arab Emirates.
Okay, we're going to move forward here with Team 67, New York University, Abu Dhabi.
114 inches tall, 6.2-inch diameter, 60.1 pounds. Flying on a COTS M1450 motor, expecting 6,000 feet at Mach 0.6.
10,000 feet.
Eylul ship is a rocket that is fully mechanical and reusable in its subsystems, built with no epoxy glue or any external screws. It packs into a suitcase and features a fully redundant and mechanical release system.
We're just waiting for the final countdown here.
Alpha 1 is going hot.
Okay.
We are green on Alpha 1. Skies are clear.
They're going to do a countdown.
Alpha, and Team 67 will be launching.
There we go.
In 5, 4, 3, 2, 1. We have liftoff.
Got liftoff. Excellent. Great job. Glad to see them in the air. Great view on the camera, too. Nice smoke trail. Makes it a lot easier to see where these rockets are going. We're looking for that event right at apogee. We'll see if we can capture that. Well, it's going to be hard to see. We may not be able to see that. We'll see if the team gets telemetry, too, and get confirmation of a parachute out, or at least a drogue. Still tracking. Looking for that event. Oh, I saw something. Yeah, that's a good sign.
Last up on the solids is Team 146, Bank Alpha 3. On Alpha 3, we have Team 146. This is the University of Windsor in Canada. Rocket, the Excalibur, 108 inches tall, 6-inch diameter, 72 pounds. Flying on a COTS M1939 motor, expecting 10,500 at Mach 0.75. Weighing in at 72 pounds, standing 108 inches long, born, bred, and built in Windsor, Ontario. We present the Excalibur. Pete Naismith, this is for you. We're going on Alpha 3. Alpha 3. Let me recycle, see if we get green. And I'm still seeing red on Alpha 3. All right, we're going to give a 10 count, a 5 count on Alpha 3 just to try it, but probably not. Sky's clear, launching 5, 4, 3, 2, 1. And we have liftoff. Coming in hot. Heads up. Watch it. We understand it did deploy the main, shredded it, but it is now down.
Wildman Hobbies is your one-stop shop for everything rocketry. With in-house CNC machine tools and decades of experience, you can trust that the entire lineup of Wildman kits and components are of the highest quality. Wildman also stocks products from your favorite brands to bring you a full line of kits, rocket motors, recovery gear, adhesives, and everything you need for rocketry from building to recovery. Whether you're just getting started in rocketry or you're looking for your next high-impulse project, visit us at wildmanrocketry.com.
Well, the Common Rocketry Club is a team formed by students and professors of the Instituto Politécnico Nacional. The main material with which our rocket is composed, coconut. Our team is further divided into 3 sub-teams: avionics and payload, and aerostructures, control and recovery systems.
Hey, y'all, so as you can see, you guys are watching a tour right now, but we're actually going to show you the behind the scenes of how this whole live stream is running. We are with the production crew.
What's up, guys? Welcome to the control center here. We've got 2 folks manning the control booth here. I'm operating the switching and the shots, so if you want to see how this works, I'm going to move over. Boom, back. Now you see this happening live. And if Abby's in the commentator booth, we can switch it back over to her. But we'll stand here for a little bit while I show you how things work. We've got our folks up on the skylift here, getting us these great aerial shots, which you'll see right now. Boom, that's a great shot right there of all the convoys coming back from the pads and heading back.
Check your headset.
You know, it's hard to multitask here in the control room, so sometimes we miss shots and we don't get all the best audio that we can. But thanks to the crew that we've got here who are watching my back and have all the audio, you know, Wyatt's been doing a great job. Warren's been killing it on the graphics. So as you can see, there's a lot going on here, and we're going to come back to me so you can actually see that. Boom. So, you know, all of our inputs are here out in the field. We've got a great team that's set up an incredible networking setup. The cameraman behind the shot, which you can't see. There we go. There you go, Nate. So we've been working hard. We're all volunteer. We're all amateurs. So we're doing our best to create the best production to show you all of the incredible work that is going on from all of these students around the world. And it's all possible by a great team. And yeah, we can check out the rest of the crew who's actually behind the door. So Abby, if you want to open the door for us, that'd be great. There we go. And so we've got more crew here. So Logan, do you want to introduce yourself and what your role is here? Logan, real quick, can you get onto Channel B for us?
Can you hear me now?
Yes, we can. Thank you so much.
Great.
This is how the sausage is made, folks.
Exactly. Well, I'm glad to be here. I'm Logan Herrera. I'm the live stream lead responsible for this entire live stream operation. We've been working on this for 11 out of the last 12 months, and it's been a great effort with the team here. It takes a lot to get the right people, right equipment, right place, right time, and then keep everyone happy, fed, and hydrated.
Thanks, Logan. Nate, if you want to pan to the left and show us the rest of the crew, that's been so awesome. So right here, Andy is one of the champions of Ezra. He's our Ezra vice president. If somebody wants to get, actually, you've been hearing Andy's voice all week, and I think he's watching the stream right now. So if you've heard his lovely voice narrating, and then boom, we've got someone on the headset. Great, Andy, can you hear me now?
I can hear you guys. I warned you before, this face doesn't like video very much.
Well, it was only a matter of time before the world got to see the man behind the curtain.
Yeah, that's it.
And
hi.
Andy, do you want to explain to us what you're doing right now?
Oh, absolutely. As we get towards the end of the competition, the data comes pouring in, and the competition is very, very competitive. So we are double-checking, triple-checking, making sure that all the altitudes and all the launch pad numbers and the predicted altitudes and the actual altitudes are all matching up. We've got duplicate, triplicate forms, we got spreadsheets, we got photos of the data sheets, and our online flight management system. They all have to sync to get those records exactly correct. Once it's all set up, it's handed off to the judge pool, and once we shut down the range, all the huge grouping of judges will go and take this data, and they'll take your scores from technical reports and all the other sundry variables together, and they'll start determining who wins the categories, who's winning the technical awards, who's winning the overall award, and taking home that huge trophy. We did get to see the trophy last night. We were quite impressed. It's slightly different design, very similar to years past, but we think it's quite a nice improvement. And we're very happy to hand that trophy off to the team. And I know they're super excited about taking it home with them, but it is a big box. I'm sure they'll be excited to figure out the details of how to get it home, but we're just as happy to hand it off to them. And then we start the whole process again. 2024 will only be bigger and better. Hopefully we'll have a lot more teams, a lot better rockets, more of the hybrids. We'll get some liquids in here, we hope, and even a better live stream. So kudos to Logan. This live stream team has been absolutely amazing all year long. Tremendous improvement over last year's attempt. Logan came in at the last second to save me because I was doing my best, and it was just and has really taken it to a whole nother level. So again, thanks everyone.
Yeah, thanks so much, Andy. I don't want to distract you too much because I know we've got all that critical information piping into the award tonight in a few hours now. All right, so let's push it back into the commentator booth to check out where we've been seeing the rest of the folks. So, Vlad, can you tell me what's Vlad or Abby? Yeah, we're coming in to check you guys out.
Awesome.
Let's see how the commentator booth works for us.
So this is our commentator booth / storage room / charging station / we ate lunch here past few days. So as you can see, yeah, welcome to our crib, Ezra crib, not MTV. So as you can see, we got some borrowed rockets over here. We made our impromptu stage. We got some lights, and then we got our other live stream camera over here. We got another monitor so that when we're in this room, we could see ourselves and see the picture when they take the shot. And this is where some of the magic happens. You also notice this table goes back upstairs. If you noticed, Alice had it yesterday up there, also this morning. And you see back here, you just have the crazy matrix of batteries. I mean, each one of these has...
Hey, Nate, stay there 1 second. We're actually going to show the other shot so that you get your well-deserved airtime. So now that the folks can see you from behind the camera, Vlad's going to... There we go. Nate's been great working the camera, taking care of some of the technical issues. So boom, now it's back to you, Vlad, from Nate's camera.
Thank you. Yeah, so again, we were showing you just all the batteries. You want to bring the camera over here, Nate? And this is all the drones, the batteries for the receivers and transmitters. We have our other camera batteries over there, GoPro batteries, Insta360 batteries, and then of course you can't forget our compressed air. Keep our stuff clean here in the desert. And then we have a door out here that takes us to the pad outside where the rest of the media and launch operations are at. So this is our production trailer, I guess.
Awesome. Thanks, Vlad. Do you want to show folks where all of this is happening in case they just wonder how they're getting this great stream?
Yeah.
Or actually, Logan, do you want to take us there?
Cool.
And just walk us around the property and show us how things work?
Let's take a look. We'll head out the front door of the LSOC, as we call it, the Live Stream Operations Center. Key recruiting point, if you come and interview with us, you get to spend time in the AC and one of our social media chips. Let me pull that out of my pocket. This is the award we give to student sponsors and staff for coming on air with us. Our social media chip. So we've got the team in here. You can see we've got Wi-Fi links going to other buildings around here. We've got cables running out just about every window. We've got ambient sound mics. We've got our roaming video receiver up here. We're going to have to step way back to see it peeking over the edge of the roof, so we have line of sight to as much of the site as possible.
And Logan, who's that guy up on that green thing back there?
Oh yeah, there he is. We've got our illustrious camera crew up there on the Skyjack. Those are our NASA spaceflight partners. We're so happy to have them come out here and film with us. They do a great job from that aerial camera angle.
Hello, I'm on Bravo, I believe, and maybe also Alpha, but
can you hear me now?
Yes, I can hear you.
This is not a Verizon commercial.
How have things been going up there all day?
Really good. Today has been less windy than previous days, so we do have a wind limit, and it's nicer the higher up you go because you get a better view of the rockets.
1 second, the water truck's coming through. Is it in the shot?
Nice.
We might get wet. Ooh, just a little moisture. That feels nice.
You can tell when it goes by. It immediately makes everything feel better when it goes by. But yeah, a little bit less wind today. That's been really nice. So we get to stay up at height, and it's much cooler up here. And when there's less wind, we get a stronger, get a better image, more stable platform for shooting. So things are less wiggly. But had some great launches this morning already. A couple hybrids, a bunch of solids. No complaints here from up on the Skyjack.
So, Jack, yesterday a Death Devil came by, and how was it like up there?
Legendary, huh? It was funny because you could see it forming like way out there, and it literally, it's like the scene in Austin Powers when the steamroller is like coming out. It's like we just sat here and stared it right in the face, and it hit us. But we were actually much lower when it came by, so thankfully it wasn't anything crazy or anything. But yeah, that was nifty. I don't think I've ever been hit full on by a Dust Devil before.
Great, that's crazy. And there's another way that you're staying safe up there, right?
Say that again?
There's another way that you're staying safe up there. You've got a safety harness, if I can see that.
Oh
correctly.
Yeah, I don't know if you can see it, but we are harnessed in. So definitely, safety first. We're being very careful up here, sort of coordinating with the drone operators and just trying to be careful. Safety first, but yeah.
Well,
all in the name of cool shots of rockets.
Yeah, you've been doing a great job getting those long rocket tracking shots. So if anybody's been watching online, seeing their full entire launch, from launch to recovery, where the chutes deploy, that's thanks to the guys up on the Skyjack.
Yeah, we can't take all the credit. Logan on the rocket cam has been doing great too. So, party, teamwork.
All right, where are we going next, Nate?
Let's see, and that scissor lift is a new angle for this year. That was an experiment. It seems to have worked out really well. And over here we've got the student spectator viewing area. Rockets are still loading, so a lot of students are at the pad right now, but ordinarily this is full of cheering students. Hey, give me some cheers. Which school are you from?
Hi, well, we're from Mexico. We're from the University of UNEC, which is the Aeronautical University in Queretaro. We're Space Dragons. We're going for 10K cuts, and we're pretty excited. I mean, this is our first time here in Spaceport America Cup. So, well, we're hoping everything goes great. We're pretty much looking to it, and I don't know, guys, but I think we need to cheer a little bit. So let's go, and, well, that's it, man.
Ready to launch, Space Dragons! Ready to launch, Space Dragons! Ready to launch, Space Dragons! Woo! Go Mexico! Woo!
excited to be here. We're hoping to see our rocket. I hope that everything goes great. Well, the effort has been great. This is our first time. This is a new challenge, and I think that we are demonstrating that we have the talent and the capacity to be here.
Amazing. How many times have you been here before?
It's our first time. Yeah, it's a lot of emotions going through us. It's like a wave of it.
Yeah, well, what are those emotions? What are you feeling?
Well, we're pretty nervous, excited. We're even kind of worried. We're nervous, stressed. I mean, it's even indescribable because everything is at the same time, and it's just amazing to be here. It's a great opportunity for us to show off what the Mexican talent can do, and we're hoping to represent in the very best statement our university, our state, our country, and all of us, all our families, all the background that we have back home, and make them proud.
Amazing. Well, we're so happy to have you out here representing. Is your rocket out at the pad right now?
Yeah, they're preparing it right now. They're in the launch area. The vans just came up, and well, let's hope that in 15-30 minutes that we're launching our rocket.
Amazing. Well, we'll be there ready to track you and give you all the different camera angles.
Thank you very much.
Good luck, everyone.
Thank you.
Thanks, Logan. That was great to hear from the team. Where are we headed next?
Let's see. We're heading back over. We're going to go on. Let's see. Oh, we can check out one of our IP cams. These are how we get, one of the ways we get footage from faraway places. We've got a few folks on our team that are networking specialists, and they've been putting in a lot of effort to get these going. These were integral to our production last year and this year. So you can see we've got a pan-tilt zoom IP camera here. We've also got some fixed camera angles, and we've got the Wi-Fi dish that lets us go long range all the way back to our main networking node on top of the shipping containers. We have similar setups out at each of the pads. The ABC bank, we've got 2 cameras, and then we've also got a setup at Hybrid. I don't know how well they've been working all week long. Sometimes they go in and out. They're a bit of a challenge to keep running, but they provide really great angles when they're working well.
And we're taking you live from this camera.
Amazing. I can see you nodding up and down. That panning and tilting in action. Also, being white is a great asset in the desert. It reflects a lot of the heat, and so objects like this tend to do a little bit better thermally. We're going to continue over here now, and I want to point out some pieces of infrastructure that might be a little nondescript at first. They might just fade into the background of your everyday life, but out here they make all the difference. You know, this beige metal box, and then over here we've got another one. This beige metal box. Scott McLaughlin was talking about this earlier today. As of this year, permanent wired power is now available at the vertical launch area. This is a huge logistical help for us. Before we were exclusively on generators. We had some reliability issues. They produce noise and smell. This, reliable, silent. This infrastructure is great and really making a difference for us. In particular, on LiveStream, we love that it's silent and doesn't end up in all of our microphones. Now this is what has been replaced and is now a backup.
Hey, Duncan, can you hear me here? All right, do you want to switch to channel B so we can talk to you on the live stream? Oh, okay, all right. Duncan is our drone operator, but he's been getting some of the great shots there, down there. Duncan, if you want to wave to say hi. There we go. He's been getting those awesome aerial shots, and thank you, Duncan.
And while we're continuing on that infrastructure tour, you can see this is the outside window of our control booth. Let's see, can we see Matt waving out that window? Let's see if Nate can get the brightness. Let's see. This is what it looks like from the outside.
Well, we can certainly see you there.
Well, you can see all the cables. We have to run out the window. Turns out, one of our biggest quality of life innovations, a piece of foam. This keeps the air conditioning in and the heat out. This room is now 10 degrees cooler this year. Now we've got our line running overhead to our rocket tracking station. We also do our morning opener interview shots up here. Can you walk up this ladder, Nate, with the camera on your shoulder? Okay, this may go a little weebly wobbly, but we're going to head up here and take a look. We've got launch ops over here. Let's see if we can do an interview with them for a second. Do you have a moment to come on the live stream?
Yeah, all right.
Great. Well, I'm going to put this headset on you, and you're going to be live as soon as it comes on.
All right.
Are you ready? You're going to be talking to Matt in the control room.
Okay.
How's it going up there?
That's going pretty well.
Can you explain to us what you do up on top of this comics box here?
So what we do at Launch Control is a number of things. One, we ensure that the various pads and their statuses are communicated to everyone. So for example, if we have recovery teams out in the field, we make sure when we're ready to launch that they are, for example, clear of launch area. We keep track of that. We keep track of traffic going to and from the pads. But our main function is, of course, launching the rockets. So we have our computer system, which as they go through the flight safety here in the queue manager, they go into the queue, then they get sent to the various pads. We track them there, and when they get moved over to the launch control, that tells us who we have to launch and the order we have to launch in them and what pad they're on. And
Gotcha.
From there, then we launch them one at a time from the control box.
Nate, if we can, let's check out that control box. I think a lot of folks wonder, how can we launch rockets from such a distance?
So
maybe you can explain as well.
The control box is a Wilson FX. It's a wireless system, so you can see our antenna connection right there. This is the safety switch, so you can see the key is out, so it is not possible to go hot at the moment. But when we put the key in, what we do is we select the bank. We have Alpha, Bravo, and Charlie are all at solids. Delta was our 2-stage. We select the bank we want. We select the pad we want here. When this light, it communicates to the pad out there. This light tells us the status of the igniter. If it has continuity through the igniter, this will go green. If it does not, it will go red. When it is green and we are ready to go, then we do the countdown. We hold the fire button, and then we just wait for the ignition. Because it is wireless, and with the winds we have and the distance that we actually have directional antennas at all of our pad banks. Now that since they're directional, they're little weather vanes, and as the wind goes, they tend to wiggle. So sometimes we will have signal flicker in and out, and so we'll hold longer to get a good solid signal, hit the igniter, and once it goes, then it goes. And once we have liftoff, we return the switches off, turn the key to safe, and we wait for the outcome to launch the next rocket.
Steve, thanks for explaining that launch process. Your voice might be heard for the first time on the live stream, but for those who are here, they've been hearing you all day, right?
That is correct. I have been announcing the launches and doing the countdown since Wednesday.
All right, great. Nate, let's see. Actually, Steve, we've got another camera angle of the full LCO area. Who else sits up there with you normally?
So I have Mike over here who sits up with me, and he communicates with Holly, who's down in the team section. And that's very important because if we need to verify that the teams have tracking on their rocket before we launch it. And so they communicate to make sure that we don't launch a team that does not have active tracking on their rocket. We also then have two more people who are away at the moment. Adrian, who sits here, she is actually down at the solids working the Trello system at the solids pads. You can see here's our incoming queue. As she works that, you'll see it will move from incoming into a salvo list, and then eventually she'll move it over and you'll see up on a launch list for solids. And so she'll come up, and when we're actually flying, I'll read off the card, she will click on launch, she will update the status as it flies, so we have data capture of did it have a normal flight, did we have a main at apogee, details like that. And then Lee keeps track of our flight cards and our documentation, and when we get the flight order here, make sure that gets run down to the team so that they know who's going and when. So it takes a team effort up here. If we didn't have all of them, it wouldn't happen.
Certainly true. This operation behind the scenes is certainly a sophisticated one. All right, I think we can pass the headset over. Thank you so much. It sounds like there's some radio chatter headed to the LCO.
All right.
I'll let you get back to your job. Thank you so much.
Have a good day.
Great, this is Logan again. I'm back. Thank you for that interview. And we've got another person we'd love to introduce and have a discussion with. This is Chris Markham, the Spaceport Network Administrator. Chris is really critical for this live stream because we have to get all the way back out to the internet from this spot in the desert. So I'm going to hand it over and let Chris explain how that all happens.
Yeah, Logan, let's use your mic.
Thank you very much.
Chris, can you hear me?
I can now, yep.
Great, awesome. You're talking back to the live stream control here. Can you explain how it's possible that you were able to get internet out here and operate this wonderful live stream?
Yeah, we'll start at the top of the hill though. So we have fiber coming into the spaceport, and we terminate that fiber in the big building, the terminal hangar facility. And then to distribute it across the campus, we don't have any fiber infrastructure at all. So we use radio backhaul. So we've mounted some antennas here at the vertical launch area.
Could you point to those if possible?
Absolutely. So you see them on top of this trailer here. The one on the right is, people recognize that shape if they know anything about radio backhaul. That's a Ubiquiti AF24. It's running about 750 megabits per second of backhaul. And the antenna to the left of that on top is an AF60, and that's running about 1.8 gigabits per second backhaul. So those backhauls are 5 miles. They go to different points back up in our horizontal launch area, and then they join the network in different places to provide some diversity for this event. And we send those out to the internet for connectivity to the rest of the world.
Awesome. What preparations have happened this year to make sure that we've had such great internet? I know last year there's some new equipment this year that we didn't have last year.
Yeah, so there's a couple things. The first off is that our generator here has been running for probably 8 years out here in the desert, and it has a circuit board in it that was a little flaky. So last year we had problems keeping the right kind of power running to the trailer. So we've bought extra boards this year just in case we need to go back to generator. But we've also managed to put in semi-permanent power at the time. We're still waiting for some, I think, breaker equipment to finish off our electrical infrastructure install here at the VLA. So we'll have permanent power. So that's the first thing. Permanent power is important for a number of reasons. Network stability is just one of them, but just to keep things cool as well, right? We're running 100-degree days here for this event. Secondly, we knew that we had some problems with last year's backhaul in the rain. So 24 gigahertz frequencies can be attenuated fairly strongly by rainfall. And last year was a wet event, the complete opposite of this year. So our signal strength was at times probably 50% of what it is this year. And then the third thing we did is we added that 60 gig backhaul to really improve our overall bandwidth back to the internet.
Gotcha. So I know last year was super rainy, but this year we've been experiencing some high winds. Does that affect the antennas at all?
So we've got them strapped down pretty good, but the answer is yes. So I actually had to align the backhauls 3 times in the last 3 weeks. The winds for this event people are experiencing, we've been experiencing this is our 6th week. So this is sort of a normal weather event, if you will, this time of year in the Jornada de Wroclaw in southern New Mexico. So we're kind of used to it. The wind gusts have been abnormally strong this year. That's what we've seen. So we have gusts every year that destroy some stuff like canopies in the parking lot or whatever. This year the gusts have been strong enough to misalign the antennas. So we've anchored them with extra straps and have been keeping a really close eye on everything to make sure that we don't lose performance.
Well, we really appreciate your help maintaining those antennas so that we can continue this live stream. Yep. If you want to hand your headset back over, we're going to continue the tour. Thanks so much.
You're very welcome. Thank you.
Thank you so much, Chris, for explaining all of that to us. And this is for you, our social media coin, for coming on air with us. Okay, now we're going to step gingerly across the divide. Okay, camera handoff happening. Now I'm going to step gingerly across this divide, and we're going to come over and see Chris Lopez. So you've got we are live right now.
Oh, there we go. Yeah, I don't have my headset.
I can model it for you.
Well, there you go. Not a bad idea.
How's it going, Chris?
Hello, everyone. Chris Lopez back.
Can you explain to us, the viewers, what we're looking at right now?
So, we talked, I know you just finished talking to Markham, talking about some of the infrastructure and IT infrastructure that's come out here. Well, what else does that do other than just keep some of these buildings cool and make sure some of this electricity works for live stream? It keeps our Rocketeers safe also. Okay, so one area that we keep safe is we have actually full backpacks for each of the recovery teams that go out searching for the rockets. So each team will get something that looks extremely similar to this. The team's backpacks are orange. These backpacks are for emergency reserve for any of us, and they're red. But the team will be wearing them. And so they're just very light and comfortable, not very heavy at all. Each team also checks them out by barcode. And so we know exactly which backpack is with which team. Now, once we open this bag up, there's actually, in this case, there's 2 radios. There's a GPS that sits right in here, and then there's also the voice to make sure we can communicate. So with these 2 items, we can always track where they're going, and with the second part, we can always be in complete comms. Going to turn on this way, Logan, and there's your microphone for the comms. So there's a full tech center, MCC center that records the position, the teams, their times, or they're moving, if they're not moving, if they stop moving for a little bit. They can also call in, hey, I may be team 124, but I found some debris for team 155. And the MCC will log that in and help teams find their rocket debris. Now, with all that, teams are going all over the place, have to safely move. And we've talked about teamwork today. So all that technology and electricity comes here. We also, a big part of the teams out here is our grounds crews. Our grounds crews are actually, during Cup Week, get started at 4 in the morning out here. And they usually stay till about 8, 9 o'clock at night, sometimes midnight, every day during Cup Week. And then in the months leading up to Cup Week, it always just depends on what they're doing, whether they're building new launch pads, improving the roads, tweaking the launch pads, changing the azimuths when we talk to the technical directors and we correlate last year's data to keep making a safer environment. Making sure all the water infrastructure is good, so we keep filling all the water buffaloes, keep everybody hydrated there. The coordination with the various tank companies and utility companies that come out here and set up, keeping the grounds clean, roads clear, Wildlife. We have a lot of wildlife out here, so we pay attention to that, and sometimes we have to manage the wildlife a little bit out here. But through the entire year, if we're just all sorts of disciplines and teams working out here. So if you're watching this live stream and you're saying, I'm not a rocket engineer, and there's no place for me in this competition. Wrong. We need the business folks. Okay? If you are excited about rocketry, I don't care what your discipline is, you could be a part of it. I myself, I'm not a rocket engineer, all right, but I enjoy helping those rocket engineers to prepare and help with the launch pad, so to speak, and make sure that those operations go smoothly so that the rocket engineers don't have to worry about those things, that they have a safe place to launch from. So day in, day out, that's what our teams work on, is we're trying to make sure those rocket engineers don't worry about anything. We have electricians on board. We have plumbers on board. The team is incredible, and they're out here day in and day out. Don't forget the finance folks back home, making sure that our ledger stays straight, that we can keep affording to do all these great things. Our salespeople that go out and get our sponsors and communicate with our sponsors and try to find new ways to add value both to the Rocketeers and to the industry. This really is about helping the industry grow, really about trying to find new opportunities, help you find new opportunities so that you guys can come up with the next idea to help all of us. So it takes a full teamwork of people. Please don't ever get intimidated that you're not the rocket engineer. Logan and I were talking, and we were with some friends, and we were kind of going around the circle. Hey, what'd you study? And, on down the line. Hey, I'm a chemical engineer. I'm a mechanical engineer. And I kind of felt like, a little fish out of water. I'm a business degree. But you know what? I wouldn't have it any other way. Because if you can get things done, if you can help connect people to find solutions, that's what this business is about. That's what this industry is about. Because we're trying new and exciting technologies that are difficult. And it just needs that can-do attitude. And you don't always get that. And a can-do attitude doesn't come with a specific degree. The can-do attitude comes from how you decide to approach your industry. And so we're very grateful for our entire team out here.
Yeah, that's a great point, Chris. It's always wonderful to see the team to come together, and the event certainly wouldn't be possible without the collaboration between Spaceport America and Ezra, everyone who's firing on all cylinders. So certainly a great call out. I got to meet some of the finance folks and the legal team the other day, and what a joy it was to learn about the full Spaceport America team that helps make this event possible.
No, it's great, and I can't say it enough, and at the risk of missing a few folks, when you hear the names Jay and Myron and Jaime, Scotty, I know you just met Chris, Melissa and Sundar and Francisco and Ronnie, Belinda, Art, Sandra, I'm going to miss somebody, and I really don't mean to. It's incredible what this team does put together. Frankie's out there. It's an incredible team, and we're proud to be a part of this industry. We really are.
That's really true. I know last year my favorite Spaceport America Cup was the guy driving the grader, because man, was that important to have out here.
Oh, there's no doubt about it. You see JD driving that water truck on down the road, and it's so easy to say, he's just driving a water truck down the road. But did you know that water truck actually makes this live stream possible right now? We have to beam this signal across our valley so that it gets out to the rest, to all of you. From our VLA spot here, we beam it almost 9 miles, beam the signal 9 miles to our tech hub, and it goes out out there. Without that water truck making sure the dust stays down, it wouldn't be possible. If that dust gets in the air, it breaks up the signal, and our Wi-Fi is kaput. No more. So don't ever, ever underestimate the importance of any single teammate or contribution from a teammate, because I know in this industry what I've learned, everybody's important. It's amazing.
I think a lot of our students here at the event are learning that, how important it is to be on a team and the value of every team member. Thanks so much, Chris. I think we're going to continue our tour and check on some other places.
Outstanding. Thank you so much.
Thanks, Chris.
Hope to see you next year.
Thank you, Chris. Thank you for sharing all that with us.
You got it, Logan. Thank you so much.
Here's
and
your backpack.
Cliff, can you hear me now? I think we've got you on camera now.
I think I'm here. Can you hear me on the stream?
Yes, we can.
Excellent. Greetings, everybody. Welcome and good afternoon Well, no, actually it's not even afternoon yet. Wait, I've lost track of time. I've been walking around. It's just now 11 a.m. here local time, so we're looking forward to the last hour of our window of opportunity for flight. I know there's some teams that are just getting ready at the solid pads. I did do a check of our base camp area off to my left, your right, and there are a few straggler teams, but unfortunately they're just not either declared safe for flight, or they're still trying to madly assemble their rocket, and it's just not going to happen, unfortunately. So that all ties back to being prepared in terms of the teams and how you come out to Spaceport and the ability to get your rocket together and get through all the things that have to happen so we can declare you ready for flight. That said, our weather is still good. Light breeze is just picking up, but that's okay, keeping us cool. It's not too windy at all for flight, and I know we're checking on some status for at least one of our hybrid teams. I know they had to redo an igniter, and so we'll find out if they're able to fly today with the time we have remaining. We also have some recovery teams. I was just down there, and there are a group of teams going out that have flown today to recover their rocket. There's also teams that have flown in previous days, and there's parts and pieces and things that they would like to find or take the opportunity while there is still time to do that. So we'll provide that opportunity for them. Our judges depart here at noon. They head over to the Spaceport America Strategic Operations Center, where they will begin their final deliberations for the teams, and they will then select the winners for the competition. This all happens very fast. So they leave at noon. They meet at 1 o'clock. Cool down, get some drinks, they do their deliberations, they complete. Our final award ceremony begins at 6:30 approximately, and there will be some initial, speeches. We want to certainly thank you to our sponsors. Huge shout out to our lead sponsor, Blue Origin, and all of our other key sponsors. They've just been huge. OnShape and PTC and all the others have been just, enormously supportive for this event. And actually, even behind me, there's still some of our sponsors with us in the tents, and they've been out here on site in the desert with us, in the winds, on the sand, supporting these students, getting to know and getting a feel for what they're going through, and just the caliber of the people that show up here. So huge thank you to them. So all that said, they will be on stage at approximately 6:30 this evening local time. After they complete and we kind of get through welcomes, I'll go on stage for a few minutes, and then we'll hand it over to our lead competition operations director, Bill Hansen. Bill Hansen will take us through the awards ceremony and handing out the individual trophies. Again, if you want to see the rules and all of the awards that are up for grabs, take a look at our website, soundingrocket.org. If you click under the Spaceport America Cup documents and forms, you'll see the rules document there. You can dive into the nitty-gritty details. Long and short of it is we've got a couple of awards. One is the Sportsmanship Award. We also have the Nancy Squires Team Spirit Award. Then we have place and we have category winners and second place runner-up for each of the 6 categories. So that's 12 trophies there. We also have 4 technical awards. And then that's all followed up by the grand prize winner of the Genesis Cup Trophy, which all of these awards, trophies have been redesigned this year. I think Chris mentioned that, or actually Andy mentioned that. And the Genesis Cup Trophy has also been slightly redesigned, a small tweak to be consistent with what we saw. And we just uncrated that for the first time yesterday. It looks really good. I'm not going to show you a sneak peek. You're going to have to tune into the live stream to see it. But it's going to be fun. So we'll be looking forward. Meanwhile, we're just waiting for our last teams to go. If I look at our flags, I see a red flag out of solid pads. And I'm looking for a flag over at hybrids. I can't see it. Where is it? There is a flag there somewhere. I just don't see it from where I'm standing. And so anyway, we'll get you updated status on the hybrid side. But again, great day. Looking forward to seeing more, and maybe we can continue a little bit of tour of our camp area and all the logistics that come into play when we put this event on. I know you just saw the live stream operations center led by Logan Herrera, and that capability to be able to bring all of this to you, it is no simple feat. I'm looking at a camera setup with lots of Wi-Fi, lots of cables. We've got a great representation from our NMSU students who are participating with us and getting to know what this event is like, and we're just super appreciative that they're able to help and augment our team, because we're not experts in camera work necessarily, so it's great to have some people that know that well. Special shout out to our NASA spaceflight folks as well, who've been with us this whole week and have been doing some of their work and supporting us and with their expertise. So more to come. Any questions for me?
I think that's great, Cliff. Thanks so much.
All right, thank you very much. We'll talk to you soon.
Sounds good.
All right.
Okay, thank you so much, Cliff. And I do want to add, you mentioned something about the award ceremony and a live stream.
I did. Coming back off mute. Yes, I did.
Well, where can people find that, and what can they expect to see?
Well, they can find the live stream on our YouTube page. So if you search for Experimental Sounding Rocket Association, just search on our page. You'll see it come up live when we do go live. They can expect to see a whole bunch of things. I don't have the agenda right in front of me, but we will certainly have some keynote speeches by our lead sponsor and also by some of our representatives. I know Scott McLaughlin, the executive director for Spaceport America, will be there. I think we have some other speeches from some of our other key sponsors, and then we'll lead off into that awards ceremony. So the way that works is you'll see all of the trophies on this table behind us as we are doing those initial kind of speeches. Once we start handing those out, we'll have the teams come down and actually get those. We take an opportunity to, thank each member of the team. So whole groups come down at a time. It's quite a process, but it's really exciting, and I hope that you'll get a sense of that passion when you watch that stream, because it really comes home, for the teams that win something that have traveled sometimes thousands of miles to get here. So.
Great. Well, we're looking forward to bringing you that live stream from the Pan Am Center for the first time this year.
Correct. That is correct. Yes, we've effectively, in some ways, outgrown the Las Cruces Convention Center to be able to have all the students and all the sponsors, all of our volunteers, everybody else who attends that. So with the help of the Pan Am Center at NMSU, that event will take place in the arena there, in the stadium, and that gives us plenty of space to be able to kind of spread out, have this event and ceremony. I think it'll be spectacular.
Really looking forward to it.
Me too.
Thank you so much, Cliff, for coming on air. We're going to continue our tour.
All right, continue
around the site.
Very good.
Okay, we're going to head back down, shimmy our way down this ladder. I'm going to give Nate a moment to do this very carefully. It's a little tricky when you've got a big camera rig on your shoulder. Coming down, coming down. Touchdown.
Teams are coming back, Logan, so they'll be ready.
Okay, great. Thank you for the acrobatics, Nate. And now I want to talk about this a little bit. Can you or someone on your team tell me what you're doing?
We are helping to clean up for the launch rails through this week, because of so many rockets have launched via these pads. It's get dirty, and mostly the launch pads need some oil and grease for a better launching. So all the dirt just stick on here. To be able to use those next year, those must be cleaned, right? So we are helping, we are trying our best. We are here, all of our team is here, 13 people. We divided the groups.
During the competition, we get so tired. 2 days, we couldn't sleep because we had some issues to solve. And we are now end of the competition. We are really so tired, but we have another issue. We need to clean all things. We need to put here how we find here. When we came here, all things are ready for lunch, and we clean here to make ready for the next years. That's what we do. But why we are here?
There is a saying in Turkish. I don't know. Do you have those in English? It's like the lion will determine by where it lays. Okay. So a lion should be in a cave or in a habitat which will be right for the lion's life. So we had to clean up after immediately after our launches. That's all. Thanks.
Thank you. And thank you. We are very appreciative of all of our teams who come to help with both setup and now teardown. It may not be glamorous, but it is absolutely critical to having a successful event in the future. These rockets leave behind residue on the launch rails when they fly, and they have to be scrubbed off. There is no substitute for elbow grease, for effort and elbow grease for getting these cleaned off. And again, we are really thankful to all of our teams who provide the labor for some of these challenging tasks that have to be done to get us ready for 2024 and be putting away clean equipment that's ready to use. I'm hearing some announcements on the PA system.
42.
All right, Logan, I think we've got some launches coming up that we're going to prepare for. So thank you for this great tour. We're going to switch back over to some launch programming.
Great. Thank you, Matt. I hope everybody enjoyed it. Once they are done, we will start in on our last salvo of solids. Minute remaining on UTSA's fill. Count coming on UTSA. Here we go. Launching in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Try the 10 count again on the hybrids. We're launching 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. They have confirmed igniter burnt, no joy.
We are just waiting to get the order list and confirmation of telemetry from the solids teams. As soon as we get that confirmation of telemetry, we will begin launching the solids. We have confirmed telemetry on Alpha 1, Team 5-8. This is Middle East Technical University in Turkey. Again, flying on Alpha 1. This is their rocket. Heritage 1, 99 inches tall, 5.1 inch diameter, 61.7 pounds. Flying on a COTS M2022 motor, expecting 12,250 at Mach 0.95. This will be our first ever rocket launch, so we are all excited to be here. Our aim is to gain experience and enjoy the competition. Our rocket will be flying at Mach 0.95. We have a special design for our nose cone. All right, we are hot on Alpha 1. Pad is green. Skies are clear. So we are launching in 5, 4, 3, 2, 1. We have liftoff. Not see an event. We are expecting it that it came ballistic, but clear of us. We're giving it a few seconds to ensure it's clear, and then we will be going to our next launch on Alpha 2. Are you right, Bob? Team 143, University of Utah, coming up. All right. Our thumbs up for pad Alpha 2, Team 143, University of Utah, flying their rocket U of UFO. It's 101 inches tall, 6-inch diameter, 52.8 pounds. This is a COTS M2320 motor, expecting 10,190 feet at Mach 0.86. This is the University of Utah's Aerospace Club's first attempt to compete in an intercollegiate aerospace competition. We are green on Alpha 2. Skies are clear. Launching in 5, 4, 3, 2, 1. have liftoff. It's coming down safely, so our next launch will be on Alpha 3. Alpha 3 is Team 5-3, Manipal Institute of Technology, Manipal in India, flying the rocket Alt Air, 110 inches tall, 5.9 inch diameter, 66.5 pounds. This is a COTS M3414 motor. They're expecting 10,200 at Mach 0.91. And we are green on Alpha 3. We have clear skies. We are launching in 5, 4, 3, 2, 1. We have liftoff. All right, they're safe. So next up, Bank Bravo 1. On Bank Bravo 1, we have Team 8-7. Team 8-7, Sakarya, University of Applied Sciences in Turkey. The rocket, SUBU TechCord 2023. This is a 132-inch tall rocket, 6.2-inch diameter, 59.3 pounds. It's on a COTS M2022 motor, expecting 10,000 feet at Mach 0.8. This is a team whose dreams go beyond the sky. We are green on Bravo 1. We have clear skies. Launching in 5, 4, 3, 2, 1. We have a ballistic re-entry south of us, waiting on the call. On the ground. We have a ballistic return is on the ground. Next up. On Bravo 2. 110 on Bravo 2. This is the Universidad Aeronautica in Queretaro in Mexico. Rocket Zitzen. Thank you for the pronunciation behind that one. This is a 119-inch tall rocket, 4.3-inch diameter, 36.7 pounds on a COTS M1350 motor. They're expecting 10,150 feet at Mach 0.88. We want to prove that we are capable of building our largest rocket and face the biggest challenge in our history. The Aeronautical University in Queretaro is proud to present this project showcasing the Mexican talent around the world. Viva Mexico! We are green on Bravo 2. Green on Bravo 2. Clear skies, launching in 5, 4, 3, 2, 1. We have liftoff. This rocket appears ballistic to the southeast. It's heads up. Down. It's down. Okay, next up on Bravo 3 for our last solids launch of the 2023 Spaceport America Cup. On Bravo 3 we have Team 65, that's Team 65, the New Mexico Institute of Mining and Technology, flying their rocket, the Gavel of Murphy. 95 inches tall, 6.2 inch diameter, 57.8 pounds. This is an SRAD M1739 motor, expecting 10,400 at Mach 0.87. This has a 10-degree half angle student developed on the nose cone with a student developed motor. We are green on Bravo 3. Skies are clear. And we are launching in 5, 4, 3, 2.
Earth, our blue origin.
We've sent robotic probes all over the solar system, and it's full of wonders. Gas giants, rocky moons.
Despite the variety, despite the wonder in the solar system,
Earth is the best planet.
There's no place like home.
There is no place like Earth.
All life on Earth are uniquely matched to this planet. There's nothing like it anywhere else in the solar system. Not even close, no way.
Earth has things that we need to work on in the here and now.
But there are also long-term problems.
We can't wait to work on the long-term problems. We have to work on both.
We have no choice but to preserve Earth.
Preserve this planet, this one.
We get to focus on the future, and the future is nothing without Earth.
everybody. Team 157, Wroclaw University of Science and Technology in Poland is going for disconnect. Their fill is complete. If disconnect goes okay, they will be ready for the 10 count. So everybody pay attention. We have one final flight hybrid on the hybrid pads. 157. Right, they are go for the 10 count. So we are launching team 157, Wroclaw University, 147-inch tall, 6.7-inch diameter, 69-pound, SRAD N1500 to 13200, Mach .82, launching in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Everybody, we are waiting on the hybrids to start the 10 count. 6, 5, 4, 3, 2, 1, 0. And we have liftoff. And the final launch of the 2023 Spaceport America Cup is in the air. Is under drogue.
All right, everybody. That is a great way to end this competition with a beautiful hybrid rocket. Team 157 just got off the pad. If you were watching, we had a bunch of challenges with the hybrids. That's always the kind of the nature of the beast. I'm super excited that we got that team and actually the rest of our solids that we had available for flight today. So we've got our last salvo on the solids. We got our last hybrid that we were able to launch today, just putting a cap right at the end of our flight waiver. So the time is right now 11:51. Our flight waiver ends at noon. So there's really no additional time for any of the rockets, obviously, to get out or certainly fuel up and do that kind of thing. I hope you've had a great time watching our stream. We're really excited for the award ceremony tonight. That's going to be at approximately 6:30 at the Pan Am Center at New Mexico State University. So make sure to tune in for us there. But I hope you've enjoyed this live stream. I know personally, it's been really a great opportunity for us to bring this to you. I know that not everybody can travel out here to Spaceport America. And sometimes sitting at the spectator area is hot and dusty, and you can watch it from the comfort of your own home or on your mobile device. Be sure to check out our website at soundingrocket.org. If any of you are interested in joining a team and are just heading into university or you're already at university, go ahead and take a look at our site. Form a team. There's no real challenge to create a team other than, hey, as long as you're all university students, you can form a team and get together with your university and then really just go from there. You can always reach out to the existing teams that either are at your university today or other schools nearby. They have a ton of tips and advice to give you on how you would even begin that process. Again, our whole purpose is fostering the growth of engineering through this competition, but it's not just engineering. I think Chris Lopez was saying earlier, hey, if you're a business major, an art major, a chemist, a physicist, any field of engineering, really any discipline, there's opportunities within this event for you to get real-world practical experience, and that's what that's what we really are all about, is getting that experience so that you can tie in directly. And make sure to, so from a, I did not get that, Logan. Tell me what you want. Oh, thank you, Logan. Thank you. Yes. Sometimes the off-camera prompts just not connecting in my brain. It's been a long week. You can volunteer with Experimental Sounding Rocket Association, so you don't have to form a team. On our website at soundingrocket.org, you can go to the Contact Us page. There's a volunteer section. We have a need for judges and people with technical expertise for evaluating rockets, for being out of the pads, for being able to manage teams as they get to that. But we're a nonprofit organization. Our organization is entirely run by volunteers. We have needs for people who have expertise in business, contracts management, live stream activities, logistics, just the logistics of being able to bring this event to you. Beyond the capability of the live stream, I think you've had a good tour of all of the things that have to happen. We show up about 3 or 4 days before the event in force, and we get all the pads and the facilities ready for us to go. We do all kinds of work to get the convention center ready, and we are doing it currently, right now, working to get the Pan Am Center prepared for tonight's ceremony. So you can also perform judging remotely. So sometimes it's not always possible for you to be here during the week. So we have a need. Actually, I'll back up. This competition starts in October of each year, basically at the start of each academic year. And that starts with, for the teams, reviewing the rules. They provide an entry application, and we review those applications. Once their applications are in, there's progress reports to review. They also have to write an AIAA formatted technical paper. Those technical papers all need to be reviewed. You don't have to be a rocketry expert to look at a paper. If you have an aerospace background, if you have an engineering or a technical background, you can review those papers and get a really good determination of whether that team knows what they're talking about. People with structural analysis skills, thermal analysis skills, ballistics and trajectory management, all that stuff, that's all very valuable skills that we can take advantage of even when you're working remotely, again, to provide that kind of support. So, again, check us out on our website. I'm super excited to have brought this to you, and I'm also really excited that we'll have the award ceremony tonight. So, Cliff Olmstead, signing out.